Hello everyone, a very good morning to all of you. First and foremost, if the audio and video both are working fine, please let me know. Great, wonderful. So let's begin with our session. Today in our class, first we are going to discuss about defense, a small chapter, not a very big chapter, and then after that we'll discuss the chapter of IT and communication. Now, IT and communication as a chapter is a very important chapter, I would say, especially in the prelims examination. Last few years, we have been seeing that a lot of questions have come from there. So we would expect questions to come. We would expect that these are areas that will become very, very significant. And there are some very important topics from the perspective of the coming examinations that we are going to discuss in that class or in that chapter. But we'll first begin with defense and we'll have a discussion on the various aspects of defense. So, first and foremost, when it comes to defense as a topic for your prelims and mains examination, what we see is that whenever a question comes from defense, it always has been current affairs. Always current affairs. So, whether this year in 2023 there was a question that was asked, or if you look at the past papers also, you'll see that every second, third year, one question comes, and that too whenever the question has been asked, question purely has been based on current affairs. Now, so that's why more than what we are going to discuss, the basics of defense that we are going to discuss here in the class, more important than that would be how exactly you prepare for the current affairs of defense. So that is the first thing that I'll tell you about the current affairs of defense, and then after that we shall proceed with the chapter. Now, if you look at this article, this is an article that was very recently published. If you see, this is a September 2023 article itself, and this has been published in the DRDO newsletter, right? This is something that has been published in the DRDO newsletter. Now, what is this DRDO newsletter? If you go to DRDO website, all right, you go to DRDO website, you'll find there is one part called as publications. If you click on publications, you'll be taken to a bunch of publications by DRDO, where you'll find DRDO newsletter written there. So if you go there, you'll find that month wise there is a newsletter that is available. The PDF of that newsletter month wise is available. Now, in that newsletter, there are a lot of things that are published. For example, all the events that happened at DRDO, or internal some kind of seminars, etc., that might have happened. Most of those things are not important. But there would be a couple of articles which are related to whatever new happened in defense, whatever new happened. And this is where this article was published. If you look at this, LCA Tejas successfully test fires indigenous Astra BVR air-to-air missile. So now this is something that, so BVR air-to-air missile is a very, very important missile, the Astra missile, where we are talking about the missile. BVR means beyond the visual range. Beyond the visual range. Now, when we say beyond the visual range, there is when a flight is taken, an aircraft flight is taken, there is a visual range that is calculated, where until which it is very easily visible for a given pilot, which can be seen. But then after that, it is not visible. So if there is something which is beyond that visual range, it will not be visible to that pilot. So then in that case, working with missiles which go beyond the visual range is not an easy task. And again, you'll see that there are only a bunch of countries in the world that have an access to beyond the visual range kind of missiles. So that's why you have to understand that this is a very, very important uh, technology that India has been working on, and that's why it is very, very crucial that India has been able to build this missile. So this was in the news last year as well, and now again it has been test fired. So when we say beyond the visual range is said to be 37 kilometers. All right, visual range is said to be 37 kilometers, and anything that goes beyond these 37 kilometers would be called as beyond the visual range. So that's why this is something which becomes crucial from the perspective of examination. Now, every now and then, these kind of articles will be published in the DRDO newsletter. So, even if let's say you are not following the newspaper for defense news or the magazines, etc., this probably is the best source, because something that DRDO feels is important is obviously important for the examination. So that's why most of the important topics will be covered here in the monthly newspaper. And it's hardly monthly newsletter, and hardly there would be like two articles or three four articles, and not nothing more than that. So it's easy to follow. All right. And monthly once, even if you give it just 1 hour, that would be enough for you. That just read the article that has been given in this newsletter, plus look at some additional information that you would find very easily in the newspaper articles, or even if you go do a basic Google search. So that will be enough for you if you can do that. So this is where, I mean, if you ask me where the questions would come from, I would say this is where the questions would come from. Every year the kinds of questions that have been coming, they can be very easily solved every year. I'm saying every year without exception, whenever a question has come. And it's not that a lot of questions have come from defense. You'll see that there was one question that was asked in 2014, then one in 2016, then one in 2009, 2020, and then in 21 and 23. So it's not that every year a question comes, but whenever a question comes, very easily those questions could be answered with the help of the articles that are there in this newsletter. So that's why I would suggest that this should be your primary source. All right, this should be your primary source for the monthly newsletter, for the topic of defense. Now, moving on, there are some topics which are very very important from defense perspective, and most importantly the missiles that we have. Missiles probably will be the most important topics when it comes to this particular area. Now, first and foremost, when it comes to missiles, everyone has a basic idea about what missiles are. That, for example, let's say if you look at this is a typical shape of a missile, where this part will be called as the payload, just as we saw in our space technology launch vehicles as well. This part will be called as the payload, and this part you can say is the launcher. This part is the launcher. So now in this scenario, when it comes to this payload, the meaning of this payload is different here, because this payload means that this is the warhead. This is the warhead. Warhead meaning that this is what carries the missile. This is the missile. This is the weapon, you can say. So this weapon is something that is basically available here. Now, overall, what happens is that when it comes to a missile, there are various ways in which we can classify these missiles. And this classification is something that becomes very, very crucial. Because if a question comes based on understanding of the missiles, it will always be based on these classifications. All right, this will always be based on these classifications. So that's why especially these classifications become crucial. So first and foremost, the classification that is done on the basis of range. So on the basis of range, we say that these are short range, intermediate range, long range, and intercontinental missiles. All right. This is how we classify the different kinds of missiles. Depends on how much distance they can cover. Now, there is no hard and fast, you can say, demarcation that only up to this will be called as short range, or only up to that will be called as a long range missile. You'll see that sometimes it's a very broad classification. That, for example, let's say something which is up to 200 300 kilometers in general, will say that it is a short range missile. Going up to 1000 kilometers normally would be called as an intermediate range missile. Then between 1000 to, let's say, up to 3000 kilometers would be a long range missiles, and or 2000 kilometers, and beyond that will be intercontinental missiles, because they can jump from one continent to another. So that's why, on the basis of range, this is how we classify. Then on the basis of the start and the end point, on the basis of the start and the end point, we say that it is a surface to surface, surface to air to air, or air to surface missiles. Meaning that either it is, so it is taking off from the surface and being launched to the surface, then it is a surface to surface missile. Launched from the surface, going to attack something in the air, maybe an aircraft or a missile, it will be surface to air missile. Clear? So this kind of classification is the second classification. And then the third classification is on the basis of trajectory. Now, this classification on the basis of trajectory is the most important classification in my eyes. You have ballistic missiles and cruise missiles. Now, when it comes to ballistic and cruise missiles, this is the most important technological difference between missiles, you can say. Now, how exactly these are different? When it comes to a ballistic missile is a missile that is more of something that has a parabolic path. All right, parabolic path meaning that, let's say you have a ball in your hand or a stone in your hand and you throw it. So when you throw, the kind of path that it takes, that path is called as the parabolic path. All right, that is called as a parabola, and hence that path is called as the parabolic path. So the missiles that have this kind of a trajectory, where they would be launched and they'll simply go and drop at the designated position, then in that case they'll be called as ballistic missiles. Whereas when it comes to cruise missiles, in case of cruise missiles, what we see is that cruise missiles can have a path like an aircraft. All right, it can have a path like an aircraft, meaning that they can very easily cruise, they can basically be maneuvered, their path can be controlled. So that's why they are closer to being an aircraft as compared to um, a ballistic missile. So that's why if you look at this particular picture, you'll get a basic understanding that when it comes to the cruise missiles, this is how cruise missiles would function. That cruise missiles basically can be very easily maneuvered, whereas in case of ballistic missiles there will be a fixed start point and a fixed end point, and based on that we'll see that something like this would work. So just understand the basic differences that we have between the ballistic and the cruise missiles. That what do we mean by a ballistic versus what do we mean by a cruise missile. So first and foremost, in case of ballistic missile, we know that it has a parabolic path. It has a parabolic path. Whereas in case of a cruise missile, we know that this here flight can be controlled. Flight path can be controlled. All right. So this is, you can say in a manner, this is a fixed path. This is, this path is not fixed. All right. So that's the first difference. That's the first difference. Then after that, the second difference, again, most of the other differences what we see is that it is somewhat also derived from the first difference itself. The second difference, for example, you can say that the ballistic missiles have more destructive capacity. They have more destructive capacity, whereas in case of cruise missile you can say that they have less destructive capacity. Less destructive capacity. All right. Then after that, the third difference, on the basis of range, generally we see that these have longer range and cruise missiles have shorter range. All right, longer range and shorter range. And then after that, one more difference. So now you would feel that, okay, fine, ballistic missiles have more destructive capacity, they have longer range. Speed wise also, we generally see that these will have higher speed, whereas in case of cruise missiles they would have lower speed. So then what purpose does cruise missile even solve for us? If we see all these, you might feel that, okay, fine, then cruise missile is a better missile, sorry, ballistic missile is a better missile as compared to cruise missile. But that's not the case, because one more thing that is very very crucial is that on the basis of accuracy, we see that ballistic missiles have lower accuracy, whereas in case of cruise missiles we see that they have higher accuracy. So that is where it becomes very very crucial, because in the battlefields etc, wherever you need to have a very precise target, in those cases we often see that cruise missiles are more useful as compared to ballistic missiles, because ballistic missiles are largely long range missiles. So in the short range we see that cruise missiles do better as compared to ballistic missiles, because cruise missiles, we can control the path, maneuver the path, and hit the target with a lot better accuracy as compared to ballistic missiles. So in this manner we see that there are these differences that we have between ballistic and cruise missiles. So that's why there are a couple of techniques also that are used in ballistic missiles. For example, there is something called as fire and forget. So fire and forget is where you lock onto the target and then you fire, so that it will lock onto the target and it will be able to destroy that target. Similarly, there is lock on after launch, that as soon as you launch you will be able to lock onto the target and you'll be able to hit that target. So these kind of technologies are also used along with normally the ballistic missiles. Then one more classification that we have is on the basis of utility, and this is also a very very crucial uh, classification, where we have strategic and tactical missiles. Now in case of strategic and tactical missiles, what happens is that a strategic missile would be a kind of missile where we see that these missiles uh, are more for, let's say, I mean, to put things very simply, these are missiles which are more for show off than anything else. That these are missiles that we want everybody to know that we have these missiles. These will be long range missiles, intercontinental missiles, ballistic missiles, uh, nuclear capable missiles. So these are missiles that can even go to, let's say, 3000 to 5000 kilometers. So most of the times chances are almost nil that we are going to ever use these kind of missiles. But just that the world should know that we have these missiles, and in case we are at war with anyone, we can use these missiles. So that's more of what we actually want from these strategic missiles. So these are also missiles which give us second strike capacity. These are the missiles that also give us second strike capacity. So second strike capacity or second strike capability is something that is very very crucial in times of any kind of war that we might be with. So for example, let's say, when we talk about the second strike capability, why exactly is it important? That let's say ki, for some reason we are at war with somebody, let's say it is China or let's say it is Pakistan, and in that case, in that scenario, let's say we have been attacked, and probably some missile has been launched on India. Now, normally the targets would be something which is related to defense, something which is related to defense areas, so that those can be destroyed. So, in that scenario, these strategic missiles will be kept at very off locations. These will be kept at locations which are not very easy to find for anyone who is an enemy, and that's why these will be kept at off locations. And after we have been attacked, we can actually attack them back. So this kind of a missile gives us those kind of capabilities, that even after being attacked we have the opportunity, or we have the capability to attack. So this is basically called as the, you can say, the capability to attack after being attacked. So that is called a second strike capacity or second strike capability, and this is something that we get from the strategic missiles. Then we have tactical missiles. So in case of tactical missiles, these are missiles which are useful during a war. These are the ones which will be used in the battlefield. So most of the times these will be short range missiles, anti-tank missiles. So these are the things that we'll see here in case of tactical missiles. So these will be short range. They could be cruise missiles. They could be anti-tank missiles, right? So all these will be called as, or even let's say, anti-ballistic missile. So these will be the kinds of missiles that will be used in the actual act of a war. Whenever we are at war with somebody, that is where we'll see that tactical missiles will become useful for us. So these are the ways in which we classify. Now, why this classification is important? Because many times when the question comes in the paper, the question will give you certain data about certain missiles. So, for example, let's say this is a ballistic missile. They'll say that okay, fine, Agni 5 missile is a long range cruise missile. So, if they say Agni missile is a long range cruise missile, Agni missile is a long range is good, fine. But Agni missile is not a cruise missile. Agni missile is a ballistic missile. So Agni missile is an intercontinental range ballistic missile is the correct answer. So that's why these kind of smaller deviations will be there from the actual reality, from the actual data. So that's why you have to be really aware of these four classifications for any missile that is in the news. Now remember this, that we don't need to go through everything when it comes to this chapter of defense. It's not required that you should know each and everything, and each and every defense equipment, each and every aircraft, each and every missile, each and every helicopter. No, you don't have to, and you can't, because let's say just the missiles, there are more than 30 odd types of missiles that India has. Then if you go to aircrafts, there are 20, 30 aircrafts. There are almost 10 different variants of helicopters. Then after that, you have different types of submarines, you have different types of navy ships, you have different types of, forget about everything, you have different types of bullets that are being used by India. So that's why you cannot know each and everything. And you don't have to try to remember each and everything. Only the things that are in the news. And how do you find what's in the news? Through the DRDO newsletter, as I told you. So that has to be the basis. Whatever you see in that newsletter, make it a point that it is easy, it is important for you from examination perspective. So please do that. Please, when you look at the chapters, when you are going through all this data regarding defense, make sure that you are doing that on the basis of these basic information. Now coming to the missiles of India, we have the integrated guided missile development program. And as a part of this program, this was the first time that India started building its own missiles. India started working on its own missiles, and this was the first program that we launched back in 1983. In 1983, under the prime ministership of Srimati Indira Gandhi. This was the time when we started building our missiles. And there were five families of missiles. All right. There was five families of missiles that we had as a part of this integrated guided missile development program. So in the year 1983, under the prime ministership of Indira Gandhi, and this is where five families. Do you know the name of these five families? What are these five missiles? Can you tell me the name? That's why I've left it blank here. Yes, Bhavan, correct. Hmm. All right. So many of you have given the answers. So let me tell you. One is Prithvi, as many of you have mentioned. Then Agni, fine. Agni also has been mentioned. This, yeah. Trishul next, correct. Then you have Nag, as mentioned. And then you have Akash. So these are the five missiles. All right. So many of you have written BrahMos. BrahMos is not. BrahMos was not a part of this program. BrahMos is something that we developed much later. So that's why to remember this, as somebody had mentioned here, Patna, our beloved city of Patna. This is how you can remember these five uh, missiles. So these are the five missiles that we have as a part of the integrated guided missile development program. All right. So we started developing these five missiles. Some of these were ballistic missiles. Some of these were very short range missiles. Some of these were anti tank missiles. For example, Nag is an anti-tank missile. Then Akash is something that is for intercepting anything that is incoming, any incoming aircraft or incoming missile. This is something that is supposed to intercept that. Trishul was a very short range missile, very short range missile. And then after that, Agni and Prithvi were two missiles which come in the ballistic missile family. So in this manner, we see that this is how we started working on our missiles. Very recently, Agni was in news again because Agni 5 missile was tested last year, correct? And Agni 5, with Agni 5 missile being tested now, or rather, the test has happened before as well, but last year's test was crucially important for Indian defense, and we were pretty successful in its test. Now, with the successful testing of Agni 5 missiles, now we have a capacity to launch a missile up to 5,500 kilometers. This has a capacity of going up to 5,500 kilometers, which is huge. 5,500 kilometers. So, and this is what the official data says. If you ask China, China claims that whatever India is saying is wrong. Uh, Agni 5 missile does not have a range of just 5,500 kilometers, but it has a range of 8,000 kilometers. But India is not saying that. India just wants to avoid controversy, and that's why India is not telling the world that Agni 5 missile actually has a range of 8,000 kilometers, according to China. According to the official data released by India, it has a range of 5,000 to 5,500 kilometers. Now, even 5,000 to 5,500 kilometers is a good range to have, and if it is actually 8,000, that's great. But why we don't say, why China says that India is just keeping the information and not letting anyone know? There are controversies that have happened in the past. Almost a decade back, we saw that there was an announcement or some discussion about Agni 6 missile. And the fact that Agni 6 missile or Surya missile, Agni 6 missile would have a range of 10,000 to 12,000 kilometers. 10,000 to 12,000 kilometers. So as soon as this information came out, a lot of countries, they started showing some dissent. European countries, many of them, US, that why do you need a missile that can launch up to 10,000 kilometers? You don't have any problems with us. So if you don't have any problems with us, why are you having a missile that can have this much of range? Whatever uh, enemies you have, those are your neighbors, let's say China and Pakistan. So then why do you need to have a missile that can go up to US? The thing is, we can ask the same question. Correct. We can also ask the same question, that why does US have to have a missile that can attack India, or why does Germany or France have missiles that can attack India? They shouldn't also have. They don't have nothing to do with, they do not have anything to do with India. They have no enemies whatsoever when it comes to, let's say, the world. So then why do they need to have these kind of missiles? They do. So for us also, it's required that we should just have those missiles. I'm not saying that I'm launching that missile, I'm just saying that I have that missile. That's it. Because uh, having the inform having the technology, having the missile is what is needed more than anything. It's not that we are going to use it, and it's not probably in the next 100 years also that we are ever going to use. Probably most of these missiles will never be used in their lifetime. But having that missile is important, because if at all you need, you cannot start building that missile when you start needing them. So that's why these kind of missiles, which you can say that these are strategic missiles, because we perhaps will never use it. These are nuclear capable missiles, very long range missiles, intercontinental range missiles, but probably will never be used. So that's why these are strategic missiles for India. Then we have BrahMos as a part of our missile program. Now, BrahMos is a missile that we started building later, and this is a supersonic cruise missile. BrahMos missile is a supersonic cruise missile, which is again very unique, because for a cruise missile, we discussed that cruise missiles have lower speeds. Supersonic would mean that the speed is beyond the speed of sound, which normally is not seen with cruise missiles. You'll find that cruise missiles are subsonic missiles, meaning that they have a speed which is much lower than the speed of sound. But here in this case, we see that we have a missile which is a supersonic cruise missile, which is very unique about any cruise missile. So with BrahMos, the speed that we could reach is up to 2.8 Mach and a range of up to 290 kilometers. Now it's not that we couldn't go beyond that. We had the capacity to go beyond that as well, but we did not, because at that point of time we were not a part of MTCR. We were not a part of MTCR, that is Missile Technology Control Regime. All right, we were not a part of Missile Technology Control Regime, and that's the reason why we were not permitted to go beyond 3 Mach or go beyond 300 kilometers. Then in 2016, we became a part of MTCR. And then from BrahMos, we started building the next version of BrahMos, that is BrahMos 2 missile. And now, in case of BrahMos 2 missile, it's a hypersonic cruise missile. It is supposed to be a hypersonic cruise missile, can reach a speed of up to Mach 7, and can have a range of up to 450 kilometers, which is very, very impactful for any cruise missile. And with BrahMos, India had become the fastest cruise missile in the world. India now had the fastest cruise missile in the world. And with BrahMos 2, we have a missile which is even faster than the fastest cruise missile in the world. So we already had the fastest cruise missile in the world. Now with BrahMos 2, we have an even faster missile with an even greater speed. So something like this is very, very unique when it comes to a cruise missile. But India has been able to achieve this with the help of BrahMos missile. Not only that, with the BrahMos missile, here will also make the use of the scramjet engine. If you remember, long time back, 2 weeks back, we had discussed about scramjet, right? And with the scramjet, what we see is that scramjet engine has been an engine which has been where we know that it can work on where it can we know that it can work on the air which is outside. Oxygen can be drawn from the air that is outside, correct? So in this manner we say that uh, this is what scramjet is. So we know that for our spacecrafts, scramjet is being built by ISRO. The same scramjet also has been given to DRDO, and the DRDO also is working on uh, adopting scramjet for using it with BrahMos. Because what then happens is that again you are not going to use the oxidizer. So when you don't use the oxidizer, you'll be able to decrease the weight, and hence you'll be able to travel faster. You'll be able to travel longer. So that's why we see that there are all these things that we see with BrahMos. Then this is the prototype of BrahMos. This is under construction right now. Then after that, there is the Indian ballistic missile defense program as well. Now in case of ballistic missile defense program, this is where we are trying to have a two-tier system where any incoming missile can be intercepted, whether it is a low range missile or a high range missile. So that's why we have two types of technologies being worked upon here. One is called as Prithvi air defense, and one is called as advanced air defense. Prithvi air defense and advanced air defense. So Prithvi air defense is basically meant for high altitude intersection, and which is also called as exo-atmospheric range. And advanced air defense is made for low altitude intersection, also called as endo-atmospheric range. All right, so in this manner we have these two classifications of the two-tier system that we are building. So one, that's why when it comes to the Prithvi air defense and advanced air defense, both of them have been tested. Prithvi air defense is an easier missile because it's in the exo-atmospheric range. We often find that firing a missile to exo-atmospheric or a higher range is easier as compared to traveling at a very low range. So that's why endo-atmospheric or the advanced air defense is a more difficult missile to work with. There's this missile also that was tested last year, that is AD1 missile, that is air defense missile. So which is a version of these two missiles that we have. So with these two missiles, what we see is that after US, Russia and Israel, India becomes the fourth such country to have this kind of a technology, because this technology is not an easy technology to work with. It's not easy to intercept any incoming missile and destroy that missile in the air itself. It's very, very difficult. So India, with these two missile systems, India became the fourth such country to have this kind of a capability. So that's why this is a very huge thing to have. And you might have heard of, for example, Israel has something called as Iron Dome, right? Israel has Iron Dome. So Iron Dome is a much more advanced, I mean, one of the most advanced technology to intercept any incoming missile, because Israel faces a lot of these missiles in its airfield because of the attacks that happen from the side of Hamas in Palestine. Because of that, they have these systems. Otherwise, no, if not for these systems, it would be a huge number of casualties that they would see. Then US also has a system which is called as THAAD, and now this system also was in news because US also provided this system to South Korea. US provided this system to South Korea, and it also led to some controversy also when South Korea and US had this deal, and as a part of this deal, this defense mechanism was provided to South Korea. So because North Korea did not like it, when North Korea did not like it, China did not like it. So China opposed it, Russia opposed it, North Korea opposed it, obviously. So in all these cases, so it's hilarious that North Korea opposed it, saying that why do you have these missiles? Because if you have these missiles, how can we attack you? So that's why you shouldn't have these missiles, so that if we want to attack you, we can. So so we see that all these things were also there as a part of this missile capability. Then after that, one more technology that has been very crucial technology for us has been radar. Now, in case of radar technology, we know that it is an acronym for radio detection and ranging. What we do with radars is that we'll be sending certain signals, we'll be sending some radio waves or microwaves, and these waves will go and they will collide with any incoming aircraft or missile, and they'll be reflected back. And the time that it has taken for it to go and reflect back, based on that we can calculate the distance at which these are present, or the movement can be tracked. So that kind of movement can be tracked with the help of a radar. So what we see in a radar is that this is a basic system that works on electronics, which is very similar to the principle of sound wave reflection. So in this scenario, what we see is that there would be a transmitter first, and this transmitter basically will be sending the signal. All right, it will be sending the signal in the given airfield, and then there will be waveguides, which are these waveguides are the waves that are transmitted with the help of radar. And then there is an antenna system that will have, and this antenna system will be able to send and receive the signals, help in sending and receiving the signals. We have a duplexer allows the antenna to be used as both to transmit the wave and also to receive the wave. Both can be done with the help of the same device called as the duplexer. So that's a transmitter and receiver. So receiver is what will receive the wave. The reflected wave will be received by the receiver, and then there will be a decision making that will be done with the help of a controller that we have. So controller will analyze the information being received, the waveguides being received, and based on that it takes a decision. Based on that, it can uh, uh, tell us about what exactly happens with this radar. So overall, this is how a basic radar system works. So if you see this, what will happen is, with the help of antenna we are sending the signal. All right, we are sending the signal. It will go and it will collide and it will come back, right? And then when it reflects back, it will be again received by the antenna, and then after that the receiver system will send the out received signal to the decision making unit or the controller that we have here. And then we see that you get the output based on the same. So in this manner we see that this is how the things work out. This is how the things work when it comes to any given radar system. So now this radar system largely will be using microwaves. Largely it will be using microwaves, but it could also use radio waves. It also uses radio waves and microwaves. These are the two signals, these are the two types of signals uh, that has been used by any radar system. Now, to counter the radar system, there is a technology that we have today in the fifth generation aircrafts largely, which is called as stealth technology. Now, this stealth technology is something which helps us make an airplane invisible to the radar system. Now, what we see with this particular scenario is that there are certain steps that are taken in the designing of the technology in the stealth aircrafts, so that the radar will never be able to catch a stealth aircraft. So what exactly we do, if you look at this figure, first and foremost you'll see that it will have very sharp edges. All right, it will have very sharp edges. At the same time, we'll see that it will have flat surfaces. All right, it will have sharp edges, and as you can see that it has very flat surfaces. Then it will be made of material that can absorb waves. All right, so wave absorbing material, and they will be black or dark colored. So we see that these are the things that we would see with any given aircraft. All right, the stealth aircraft that we have, we'll see that there are all these features that will be there, and these features will help the aircraft to manage any kind of waves. So what happens is that when the waves actually reach these kind of aircrafts, they will be reflected back in various different directions. All right, so they will be deflected in various different directions. So it will not just be one direction, but rather there will be multiple directions into which it will be deflected. So that's why it will be very very difficult. It will be very very difficult for, like this, it will just go in various different directions. So it will be very very difficult for the radar to catch back these systems. Also what happens is that because it is made of material that could also absorb certain waves, the reflection will be even poorer. So that's why we'll take all these steps to ensure that we can manage this kind of a system. All right, so this is about this chapter. Just remember that more than anything, as I told you in the beginning itself, that how to read a DRDO newsletter is probably more important than anything else. So if you have any questions, please let me know. After that, we'll begin with the next chapter. But before that, any question? Fire and forget. So in case of fire and forget missiles, what happens is that um, the technology that we use in fire and forget, what it does is that it will pre-lock on the target before the launch itself. It will pre-lock on the target and then it will be launched. So that's why in case of ballistic missiles we say that they work on fire and forget. So that's why they will fire and forget, that you don't need to control the path, you don't need to think about the path. The pre-locked target will be targeted, which will be hit with the help of these missiles. Dark color absorbs light, so how is it reflecting? It is not reflecting. That's the whole part, that it will be able to absorb more. It's not that 100% absorption happen. No, 100% absorption never happens. It will always be able to absorb more than it reflects. Lighter surfaces will reflect more and absorb less. Darker surfaces will absorb more and reflect less. But it's never that there will be 100% absorption. 100% absorption can never happen. On Monday we have the last class. Yes, topics wise, Monday we have the last class, but on Tuesday we have a doubt session. So that's technically that's the last class. What is difference between Patna? I mean, all those missiles you mean. So if you look at these missiles, you have Agni, you have Prithvi, you have Trishul, then Akash and Nag. So all these missiles, these are for various different purposes. For example, Agni, in short, you can say that Agni is a ballistic missile, or you can say strategic ballistic missile. All right, this is a strategic ballistic missile, ballistic long range missiles, long range surface to surface. So these are the classifications that we had done. In case of Prithvi missiles, we say that these are tactical missiles. Right? These are tactical missiles, but these are ballistic. These are short range missiles. These are short range surface to surface missiles. And Agni, we know that there are 5 variants of Agni. In Prithvi, we see that there are 3 variants. One has been given to the Air Force, one to the Navy, and one to the Army. So that's why there are these 3 missiles, these 3 variants that we have. Now, Trishul is something that has been discontinued. All right, Trishul is discontinued because we did a lot of tests with Trishul, but we did not succeed in that. We did not succeed with Trishul testings. A lot of Trishul missile testing did not do well. So that's why we see that this is something uh, that we stopped working on, and that's why we actually started buying Barak missiles from Israel. So Barak missiles are like to like replacement of the Trishul. That's why Barak missiles were bought by India. Otherwise, when it comes to Trishul, in case of Trishul, we can say that this is a uh, low range missile. I mean, the range was only going to be up to like 8 or 9 kilometers and not beyond that. So it's a very low range missile which was developed by India. So very short range, short range, very short range surface to air. All right, it is very short range surface to air missiles. So this is what we know about Trishul. But again, Trishul has been discontinued, as I told you. And then after that we had the Akash missiles. Now, as a part of Akash missiles, Akash is a missile which is also fitted with a radar. It also has a radar, so that it can, and it is also surface to air missile. All right, it is a surface to air missile, and range also is short. So here also you can say that it is a short range surface to air, air surface to air missiles. And this is with a radar, with a radar. All right, and Nag basically is an anti-tank missile, and this has capability to be launched from various different sources. For example, it can be launched from a moving vehicle, it can be launched from an helicopter, it can be launched from various different ways. So that's why these are different types of missiles that we started covering as a part of our requirement. Do we need to learn all these missiles working? As I told you, anything that is in the news, only that much. Beyond that, please don't do anything. Only whatever you get in the next 1 year in the news, only that much has to be done, nothing beyond that. Does ISRO website help in the same way of providing current event articles of newly launched satellites? Yes, it does. It does. ISRO's website also has uh, all that information. The difference is that whatever ISRO does gets a lot of media coverage. It gets a lot of media coverage, but not a lot of media coverage is there in everything that we do in defense. Because whenever tests happen, you'll see that there will be a small article here and there, and many a times it's easy to miss kind of articles. That's why it's an easier source to go to DRDO website, whereas whatever ISRO does gets a lot of media attention. So that's why it will be cover page article, or maybe at least a very big article that the newspapers would cover. So that's why it's easier to cover that from the newspaper, but many a times you might miss the news articles related to defense in the newspapers. Stealth technology is threat to any of the countries. How can we tackle that? We have advanced systems today, uh, because we today see that there are radars also which are much more sophisticated. And apart from uh, radar, what we also see is that there there are other systems, there are AI based systems, there are satellites that are working. So there are various different mechanisms that we are using today to ensure that to ensure that uh, we we do not miss anything that is incoming. So that's why it's not only about these. Now we see that it goes beyond that. On the basis of trajectory, what we are saying is that you are either having a ballistic missile or you have a cruise missile. So ballistic missile is where you have a prefixed parabolic path, all right, just like throwing a ball, as I told you, just like throwing a ball. That's the kind of path that a ballistic missile takes. And cruise missile has a trajectory which is similar to the trajectory of an airplane, where you can control the flight path. You can control the flight path, and it can very easily be maneuvered in our according to our requirement. Which type of signal absorbing material is used in stealth technology? Uh, there are a couple of things that we use. Let me just write here itself. We Many times we use rubberized foam. Rubberized foam is used. Then what we discussed again in carbon nanotubes, there in nanotechnology, carbon nanotubes are also used. So these kind of materials, we see that they become very very significant in making these kind of materials. And there are other specific materials, absorbers that are being used in case of any waveguide absorbing material. So we see that there are waveguide absorbing materials that we can use in these cases. So just remember this. So that's why these are, in a manner, I mean, they are also called as rams. They're also called as rams, that is radiation absorbing material. So that's why ram is the name that is given to them. Are there any international treaties that put bounds on India in defense research and development? Not really. Internal defense related problems, related things can never be controlled by somebody else. Only thing that is controlled is how we tackle our nuclear weapons. Nuclear weapons, weaponization is the only thing that we see that a lot of restrictions are there on every country. We discussed about the aircrafts and missiles. Should we also focus on naval fleet and submarines? Only if they are in the news. Only if something is in the news, because we often see that naval fleets and submarines only once in couple of years it comes in the news. Otherwise, not. Strategic versus tactical, in short, strategic, the ones that we need more for from a strategic perspective, where these are long range missiles, ballistic missiles, nuclear capable missiles, So those kind of missiles which will often be not be used during a war, but the ones that will be used during a war will be called as tactical missiles. So for example, between Agni and Prithvi, Agni is very long range missiles, strategic in nature, so during a war we shall not use it. But in case of Prithvi missiles, these are missiles that have been given, one version each has been given to the army, air force and the navy, and that's why these are tactical short range ballistic missiles that can be used during a war. If anything that is in the news is important, so why are we studying this? This goes for every chapter, that current affairs, you need to know the basics of that current affairs. Some of you ask questions 4 or 5 times. You ask the question once, I'll see that question. You don't need to ask the same question 5 times, because then other questions also get lost in that, because one person has asked the same question 5 times. Rough surfaces are used in wave absorbing materials. Yes, yes, we do that. This means that cruise missiles are for moving targets, but ballistic missiles are for fixed targets. Usually, yes, but not always. Not always. We can actually launch it for fixed target. I mean, cruise missiles can also be launched for fixed targets as well. So it's not always the case that we do that. And then even for in the case of, let's say, a ballistic missile, when it comes to lock on after launch kind of targets, we see that ballistic missiles with small changes, small modifications can be used in those cases as well. Some of you have mentioned that you were not able to join the class on time. Is that the case? Because of some issue? Oh, so those of you who started late, there is something that you might have missed. I'll just give you a brief about that first. It showed that the class is not live yet. 20 minutes late. Okay, I did not know that. So one thing, I mean, anyway, please go through the recordings of the first part. This part especially, what I was saying is that current affairs of defense is very, very important, and for that there is DRDO newsletter that you should go through. So where and this is for everyone, I'll just write here that you go to DRDO website. All right, you go to DRDO website. There you'll find one place where you see publications written, and when you go to publications, there you go to DRDO newsletter, and this is something that is arranged month wise. So you'll see that month wise PDFs are available. Month wise PDFs are available, so just go through those PDFs, and some of the small things like this, what I've shown here on this screen, just do that. All right, so this is the current affairs that you need apart from whatever we discussed in this class. Hmm. So let's move on to the next chapter. So next chapter for us is the chapter of IT and communication. Now, when it comes to IT and communication as a chapter, for prelims examination specifically, I would say that this is a very, very important chapter. But at the same time, it can also become important for your mains examination. Until now, we haven't seen questions coming in the mains examination from here, but very easily a question can be framed that can become important for your mains as well. So we'll discuss that. Now, as a chapter, it's a very different chapter compared to many other chapters that we have discussed until now, because in most of the other chapters we have seen that there has been a continuity, right? We have seen that there is a continuity, that there is one topic, and where there are multiple facets of that topic that we have been discussing in that chapter. But in this particular chapter, what we see is that there are multiple different topics, and we have to just independently, we have to study each and every one of those topics. All right, independently we have to study each and every one of those topics. That some of those topics, I mean, for example, what is wireless communication, what is Bluetooth, what is Wi-Fi, what is 5G, what is Internet of Things, what is quantum computing, what is supercomputer. So all these are independent topics, they don't have a relation with another topic, but these all combined, they make this particular chapter. And this chapter specifically, I would say, is important more from prelims perspective than from mains. But now what we have seen is, every year now they are asking questions from here. At least one question every year is coming from the chapter of IT and communication, and we would expect questions to come from here, especially some of the topics which are very, very crucial topics, like for example 5G. So 5G as a topic, I would expect that a question should come in the examination. This year also we were expecting that the question might come. Question did not come. We still are waiting for the mains examination, but questions did not come in the prelims. So if questions are not asked this year, chances will be higher that the question will be asked next year from the same topics. So that's why these topics will become very, very crucial uh, from the perspective of your examination. Now the first part of our discussion here is about wireless communication. Now, when we say wireless communication, understand the basic meaning of wireless. What do we mean by wireless? That we are not going to use any wires for communicating, meaning that between the transmission and the reception, there will be no wires. All right, between the transmission and the reception, there will be no wires. So now, if we are working on a wireless technology, how do we do that? How do we work on a wireless technology? So that being said, we see that there are various different types of wireless communication. So we have Bluetooth, we have Wi-Fi, we have RFID, we have NFC. All these can be called as wireless technology. Now in case of wireless technology, what we observe is that wireless technology is based on electromagnetic waves. Wireless technology is based on electromagnetic waves. Now, when it comes to electromagnetic waves, understand the importance of electromagnetic waves as well, because electromagnetic waves are important because, and if I ask you first, let's say, let me ask you a question. Why do we use electromagnetic waves for wireless communication? Why do we use electromagnetic waves for wireless communication? Can you answer this question first? Then I'll tell you the answer. Strong and high range velocity, that's fine. Speed and obstruction can be surpassed, right? Can travel in vacuum, perfectly correct answer, yes. Composition of electrical and magnetic fields, yes, that's also true for this. Present everywhere, yes, you can say that. So electromagnetic waves, understand this. So if, let's say for example, between electromagnetic waves and, if I ask you about sound waves, can you tell me what is the basic difference between sound waves and electromagnetic waves? Anyone who has an idea? Otherwise, I'll tell you anyway. What is the difference between electromagnetic waves and sound waves? Hmm. So many of you have given the correct answer. So first and foremost, most importantly, as many of you have mentioned here, that electromagnetic waves can travel in vacuum, but sound waves cannot travel in vacuum, correct? Meaning that sound waves will always need a medium to propagate, either air or water or through a solid, but it would always propagate through a medium. So if there is no medium, then in that case, they cannot travel, right? They cannot travel if there is no medium. So that's why they are also called as mechanical waves, because they need a medium to travel. So for example, why you are able to hear me is mainly because of the fact that between me and there is a mic here. So between me and the mic there is air. So because of air being there between me and the mic, the air molecules, when I speak, the air molecules would vibrate, and each and every air molecule will vibrate and pass on this wave to the mic. And because of that only you can hear me. If let's say this studio where I'm taking the class from, if this studio was in vacuum, then there will be no air between me and the mic, and whatever I say, I would be, in a manner, I would be on a mute for you. It will be just like you have muted your television and you're watching the lecture. So that is basically how it would sound if at all, let's say, there was no wave here, I mean no medium here. So first is that sound waves, they would need a medium. Electromagnetic waves, they do not need a medium. That's the first. Second, on the basis of speed, that what we know is that electromagnetic waves will travel with a speed of light, 3 into 10 to the power of 8 meters per second. Whereas when it comes to sound waves travel at a much lower speed. The sound waves, again, the speed also uh, depends on the conditions, but at normal conditions, meaning 25 degrees Celsius at the sea level, under normal conditions of temperature and pressure, the speed will be approximately 340 meters per second. So that's the second difference that we see between them. Then after that, you can say that the electromagnetic waves, they have a very wide frequency range. That's why they can actually be used in a so many different communication ways. Whereas when it comes to the sound waves, they have a much lower range. For example, human hearing range, you might know that we have the range between 20 hertz to 20 kilohertz. So only between this range we can hear the sound. So that's why we see that there are multiple different ways in which there are differences. Again, the propagation of energy happens through electrical and magnetic fields. That's why it is called as electromagnetic wave. Whereas in case of sound waves, we see that the propagation of energy happens through vibrations. So that's why we see that there are all these various different uh, pictures, all these various different differences that we have between the two. So as many of you actually had mentioned as well. So just to give you a brief about the differences, should I write down the differences here? Have you noted, or should I write it down? All right, fine. So many of you are saying to write it down. I'll just write it here. These are just the basics. I mean, you should know some basics like these. So we have electromagnetic waves and we have the sound waves, right? So between the two, first, no medium required, and they can't travel without a medium. So that's the first difference. Second is on the basis of its speed. So speed here would be 3 into 10 to the power of 8 meters per second. And here the speed would be, you can say, 343 meters per second under standard conditions. All right. If the conditions change, we see that the speed of sound can also change. So that's why that also needs to be remembered. Then speed is one, and then after that, from in on the basis of frequency also we'll discuss about the frequencies of electromagnetic waves. So wider frequency range, they have wider frequency range, and they have lesser frequency range. So that's another difference that we have between the two. Then after that, on the basis of their propagation we already discussed, and then their energy transfer. So energy transferred via electric, and it's going in, I'm just trying to accommodate this point here. Energy propagated through electric and magnetic fields, whereas in this case energy propagated through vibrations, right? Energy propagated through vibrations, and here we see that that happens through electric and magnetic fields. Now comes the question, why electromagnetic waves? Now based on this information that you have, now tell me why electromagnetic waves are used for wireless communication. Okay, wider frequency range, that's correct. Speed, absolutely correct. One very important factor, I'm just waiting for somebody to answer it. No medium required, that's correct. Most importantly, no medium required, because when you are going to have any long range communication, for example, you know that a lot of communication that we are doing, that is being done with the help of the satellites. Now satellites are placed where 35,786 kilometers, remember? So 35,786 kilometers. So now the waves have to travel to the satellites, and they basically will be transmitted through the satellites. So now after the earth's atmosphere ends, you do not have any medium, that is where the vacuum is. So in the vacuum also it can travel very fast and come back. So that's the most important thing. So that's why, to answer this question, first, no medium required. No medium required. And second, very fast. And third, wide frequency range. So wide frequency range means that various types of communication can be established. Right? So I hope this part is clear, that how exactly we are using electromagnetic waves and why are we using electromagnetic waves. All right. So now overall, when it comes to electromagnetic waves, what we see is that the first two important concepts related to electromagnetic waves are wavelength and frequency. Now why wavelength and frequency? Because very often in this entire chapter we'll keep talking about wavelength and frequency, we'll keep mentioning the wavelength and frequency. Not only that, in your examinations also, if you look at the previous year papers, you'll see that wavelengths and frequencies in certain cases have been mentioned whenever they have asked questions. And in UPSC prelims they have been asked, and especially if you're, let's say, also writing the state PCS examinations, there also you'll see that frequency and wavelengths are two of the most common things that they actually ask. So that's why these kind of basics can be important from that perspective also. But even in the UPSC prelims we have seen that they have asked it in the past papers. So what do we mean by wavelength and what do we mean by frequency? Let's try to understand this. So first and foremost, wavelength. Wavelength is the length of the wave. That's why wavelength, it's the length of the wave. That's why this term wavelength is being used. Now what do we mean by wavelength or length of the wave? This basically, you can say in a manner, is the distance between two similar points on a given wave. For example, let's say when we start from here, correct, as you see here, when we are starting from here, going all the way down, coming all the way up, coming back to the same point, this is called as wavelength. And you can pick any point that you want. For example, let's say I can pick this point. I can pick this point. So what do I see? I go all the way up, I go all the way down, coming back to the same point. This will be called as the wavelength. Alright, so the distance that you have between two similar points will be called as the wavelength. And because it is length, it is measured in meters. So meters or maybe fractions of meters like millimeters, micrometers, nanometers, and so on. So this is how we uh, understand what wavelength is. So it is nothing but the length of the wave. Then you have this term called as frequency. Frequency basically means how many waves can pass in a given span of time. That, let's say I have a 1 second time frame. In this 1 second time frame, how many waves will be able to pass through it will be called as frequency. So that's why it is defined as number of wave cycles per second. Number of wave cycles per second, and it is measured in terms of hertz. This number of wave cycles per second is called as hertz. So number of waveforms in a given length of time, number of wave that form in a given length of time is called as frequency. So now what we basically see is that wavelength and frequency, these are inversely proportional. These are inversely proportional, meaning that if one increases, the other decreases. So for example, if you see this, let's say I let's say for example I start from this point. All right, let's say I'm starting from this point, and let's say I end at this point, right? Let me take exact areas, making it easier for you. Let's say I'm starting from this, and let's say I'm ending at this. All right, so now if I basically did the same thing again. So let's say if I'm starting from this point and ending at this point, if I ask you to count the number of waves, can you count the number of waves in the first case? How many waves are passing through in the given span of time? Let's say this is the 1 second time frame. Let's say this is 1 second. In the first one, how many waves are passing through in the first one? Yes, as many of you mentioned, three. In the second one, how many? One, correct? So how do I count? How am I counting? I start from here. So I start from here, I come back to the same point, this is 1. I again come back to the same point, this is 2. I come back to the same point, this is 3. So here you have 3 waves. In this case, I start from here, I go down, I go up, I come back to the same point. So there is just one wave, correct? There is just one wave in 1 second in the second figure, and 3 waves in 1 second in the first figure. Now, do you see that the first figure has a shorter wavelength, right? It has a shorter wavelength. The distance between two similar points is shorter. So that's why it has a shorter wavelength. So these will be called as short waves, and the other ones will be called as long waves because the distance between two similar points is longer. So when the wavelength is short, the frequency is high because more number of waves are passing through in a given span of time. So when wavelength is short, the frequency is high. When the wavelength is long, the frequency is uh, low. So this is how we basically see the relation between frequency and wavelength. But not only frequency and wavelength, there is the third factor also that comes in, and this is the factor of energy. This is the factor of energy. So that's why just remember this, that when you have long wavelength, when you have long wavelength, then you have low frequency and also low energy, right? So on the other hand, when you have short wavelength, you would have high frequency and hence you would have high energy as well. All right. So this is basically how we define the relation between wavelength and frequency. So wavelength and frequency, these are inversely proportional to one another, whereas frequency and energy, they are directly proportional to one another. Meaning that if frequency is high, energy is also high, and if frequency is low, the energy is also low. Now, in this particular scenario, when we are looking at these, this is how we look at the various parts of the electromagnetic spectrum. So, electromagnetic spectrum has a very wide range. The electromagnetic waves have a very wide range of frequency. As you can see that you are starting from a very low frequency and you are going to a very high frequency. Now, what we see is that this is how the arrangement also is, that you have the longest wavelength with radio waves. After radio waves we have microwaves, then we have infrared, then we have the visible light, then we have ultraviolet, then we have x-rays, and then lastly we have gamma rays. So this is how we see that these are the various different types of waves depending on their wavelength. So radio waves have the longest longest wavelength. That's why they have the lowest frequency and also lowest energy. But low energy also means low energy dissipation. So energy dissipation also in radio waves will be lower. Now what we understand from here, also just get the basics of what we are discussing, that if for example when we are looking between radio waves and gamma rays, when we are looking between radio waves and gamma rays, if I ask you what should be used for communication, let's say in our mobile phone, should we use radio waves in our mobile phone or should we use gamma rays in our mobile phone? Yes, so a lot of you, I mean every one of you has written radio waves. Why? Why do you think that radio waves should be used in mobile phone communication and we should not use gamma rays in the mobile phone communication? Okay, long wavelength, correct. Travels very long distances, perfect. Because they consume less power, very good. Can pass through particles, that's correct. Yes, gamma rays are also harmful, that's also correct. So more or less you understand this. So what basically happens is that radio waves, why you'll see that radio waves are the most widely used. The radio waves are the most widely used in any mode of communication. So radio waves, they basically have long wavelength. So long wavelength would mean that they can travel long distance. They can travel long distance. Long distance. They have low frequency or low energy, means that energy dissipation or energy loss while traveling, energy loss while traveling will be the least. All right. So that's why without losing any energy, it can travel very long distances. So that's why it will also be cost effective. So one more thing is also about the cost. So let's say if we wanted to use gamma rays. So for example, let's say for my mobile phone, I wanted to use gamma rays. So if I'm using gamma rays in my mobile phone, what will happen? The first thing that will happen is that I'll die, because I'm using gamma rays for mobile phone communication. But let's say keeping my death apart, what happens is that gamma rays, they have very short wavelength, so they have very high energy. Because they have very high energy, you would need a lot of energy to push gamma rays even through a small distance. So if we want to use gamma rays, there will be a lot of energy requirement. So overall energy requirement of the entire world will increase if we are using gamma rays instead of radio waves. Even keeping, let's say, the harmful aspect of gamma rays aside, even let's say it, suppose that they were not harmful for us, then in that case what happens is that even if you're trying to use gamma rays, the amount of energy that you'll need to make them work will be enormous, and that's why they will not be practical. So that's why, practically speaking, we see that radio waves are actually much more useful as a mode of wireless communication as compared to any other wave. So that's why, whether it is Bluetooth or Wi-Fi or mobile phone communication, RFID, all these basically they work on radio waves. But it's not that others we cannot work with. We can work with microwaves as well. We can work with infrared also. We have visible light communication as well. Only the smallest ones, gamma rays, x-rays and ultraviolet, these are the three which we do not use for communication. All right, these are the three that we do not use for communication, because while you go to ultraviolet, this ultraviolet has a very short wavelength, and that's why it becomes very very difficult to work with ultraviolet light. So that is the reason why ultraviolet, x-rays and gamma rays, they will not be used for any kind of communication. We widely use radio waves. We can also use microwaves, infrared or visible light. So that's why we see that in all these cases, they would be much more useful. So overall, just understand these basics. Now when it comes to all these waves, we should know certain properties of all these waves. So every wave, there are three things that you should know: what is their wavelength, or what is their wavelength range, their frequency range, and their applications. These three, for your prelims examination, I would say that these are important pieces of information. So first we have the radio waves. Now in case of radio waves, the frequency is up to 30 gigahertz and wavelength greater than about 10 millimeters. When it comes to the use or the application, we know that they can be used for various different modes of communication, for voice, data and entertainment media, etc. So radio waves most widely used, as I told you, for communication purposes. Then we have microwaves. Now in case of microwaves, the frequency is between 3 gigahertz up to 30 terahertz, and wavelength between 10 millimeters to up to 100 micrometers. Microwaves, we know that they can be used for high bandwidth communication. So when we say high bandwidth means high frequency. Higher frequency range is called as high bandwidth. So because you know that when it comes to radio waves, they have lower frequency. So now with when you need higher frequency for some reason, then in that case microwaves can be used. We just discussed that they are also used in radars. They also act as a good heat source. If you remember, we discussed about the cosmic microwave background, right? We discussed about the cosmic microwave background, that we see the early universe having a background of made of microwaves. Why microwaves? Because microwaves are associated with energy, high amount of energy. That's why microwaves are used, or rather found there. So that's why wherever you have a heat source, so for example the microwave ovens that we use at our homes, those microwave ovens also have microwaves, so they can heat the food, or they can rather cook the food with the help of these microwaves. So That is the reason why we see this. Then after that, we have infrared. All right, so in case of infrared, what we see is that this has 30 terahertz to 400 terahertz of frequency, and wavelength between 100 micrometers going up to 740 nanometers. And in case of infrared, again we do have infrared communication as well, a very short range communication that can be established with the help of infrared. But when it comes to infrared radiations, we know that we see that these often can be observed or felt as heat. So any heat source that you have, for example, a heater, if you're using a heater, the heat that you feel, that heat is because of infrared. Any kind of heat that you can feel is because of infrared. So, and now what happens is that because of this heat that can be felt, we can also use it in night vision cameras. So, for example, let's say in our wildlife sanctuaries or national parks, we have these camera traps where they are made of infrared, so that in the in the night, when there is no light whatsoever, no visible light whatsoever, the movement of the animals can be tracked with the help of infrared. How exactly? Because when the movement is happening, movement means that some amount of energy is being used, some amount of energy is being dissipated, and that energy dissipation is propagating in terms of infrared. So that infrared can be caught by these infrared cameras or night vision cameras, and accordingly they can be transmitted, or accordingly they can be processed in terms of uh, visible light. So that's why they can be used in such cases as well. Then we come to visible light. So visible light has a frequency between 400 to 800 terahertz and wavelength between 740 nanometers to 380 nanometers. So this is the range of the visible light. Now, of course, visible light is the most important part of the electromagnetic spectrum for us, because we can perceive the entire world. Our eyes can see the world because of the visible light. They can also be used for communication. There is something called as visible light communication, a version of it which is called as Li-Fi. We'll discuss later. So that uses visible light. So that's why for communication purposes, even visible light can be used. Then after that, we have ultraviolet. Now, in case of ultraviolet light, what we basically see is that ultraviolet has a frequency range between 8 into 10 to the power of 14 to 3 into 10 to the power of 16 hertz, and wavelength between 380 nanometers and going up to 10 nanometers. Now, all these ranges, also remember one thing, that all these ranges that we are discussing, they're not supposed to be exact ranges. For example, in some sources, you'll see that this 380 will be written as 400. Sometimes it will be written as 375. So there can be these small variations. So small variations, just ignore. Depending on what source the information has been taken from, we see that UPSC also has asked multiple questions, and multiple times the questions have had different ranges, but very similar ranges. So that's why there are these small changes in range that is actually possible when we are looking at nanometers, because this is a very small range. So uh, smaller differences are actually possible. Now, in case of ultraviolet light, what we see is that there are three types of ultraviolet rays that we see. There are UV, so these are called as ultraviolet A, ultraviolet B, and ultraviolet C. UVA, UVB, and UVC. Now, in case of UVA, UVB, and UVC, all right, how exactly how exactly do we look at these, and what are the differences that we have between UVA, UVB, and UVC? Now, what we see is that when it comes to UVC, the wavelength is between 100 to 280 nanometers. This is the shortest part among the three. This is the shortest part. So if it is the shortest part, if it has the shortest wavelength means highest frequency. Highest frequency means highest energy. So that's why they can be the most harmful for us. They would be the most harmful for us. But what happens is, what we basically see here is that they are very harmful, but good for us. What we see is that they are completely absorbed by the ozone layer. The ozone layer that we have in our atmosphere, this ozone layer completely absorbs UVC. So that's why UVC does not reach us at all. The natural UVC that is being emitted by the sun, that is reaching to us through the sun, that does not reach us because of the ozone layer. Now, one more thing about, but it's not that you do have only the natural source. There are man-made sources also that we might have. So, for example, welding torches. So you might see that whenever welding is done, the person who is doing the welding, they'll be sitting with a shield, right? They sit with a shield. Why the shield is required? Because the shield would protect them against ultraviolet C. So that's why that shield. Also in germicidal lighting, there also we see that UVC is used. Even in water filtration, UVC is used. For example, if you go to buy a filter, you'll see that these advertisements will tell you that this is an RO plus UV plus UF and XYZ kind of filters. So when they say RO plus UV, that UV is ultraviolet C. And this ultraviolet C is required because RO can only filter, but UV can kill the microorganisms. Ultraviolet C can kill the bacteria, etc., that is there in the water by any chance. So that's why RO plus UV. So many times it is also recommended that if you already have good supply of water where there are not the TDS level, the total dissolved solid in your water is not very high, it's in the range of 100 to let's say 150, then it is also recommended many a times that you do not use the RO systems and you just use UV, you just use ultraviolet, so that whatever bacterial uh, things could be there in the water, that can be killed and water becomes drinkable because the total dissolved solid is in the required range. But many a times the problems that we see today with water filters, if you just do a basic test, you will find this out, that the total dissolved solid in most of the water supply, the drinking water supply that through cans etc is done, especially in the larger city areas, you'll or even if you have let's say an RO based filter at your home, you'll find that the TDS level, the total dissolved solid, the TDS level is sometimes even below 50, which is not good, which is basically over filtration, which is something that is over filtered water. So what then happens is that the basic minerals that water should have, even those basic minerals will not be there in water. So that's why if the TDS range is in the range of let's say 100 to 150 or 180, that's drinkable, that's the good range to have your drinking water with. But what we see today is that because of the RO systems that are just available everywhere, people just are looking for filtration. You are being just advertised this filtration, and you just think of that filtration and nothing else. But you just have to remember that over filtered water is also not good for your body, because the basic minerals that get delivered to the body through water, even they will be missing from the water. So that's why actually uh, these kind of tests should be done. So and testing this, I mean, there, I mean, I have a TDS meter at home. I have done a lot of these testing just to be sure of what I'm getting. So when I did the test of the water that I get through the supply water that I get, that supply water itself was just 125. The TDS level was 125, clean which is clean enough for me to directly drink also if I want. But no, there can be bacteria etc that can be also there. So a basic filtration is still required. But if the TDS levels are very high, let's say the supply that you are getting has a TDS level of 200 250 300 and so on, then it's bad. Then you really need the RO system along with RO and UV, so that they can filter out the water. But all these things actually become important, because today what happens is that we know that water should be filtered, and a lot of advertisements have told us that how difficult our life could become if we are not using an RO system. And a lot of advertisements of these systems are done, that there is an RO system and then there is a mineralizer, meaning that the RO is first removing all the minerals, and then they also have a mineralizer that will add those minerals, and then this RO plus mineralizer filtration will be sold to you for rupees 20,000 or 25,000. So that's why knowing science is required. that you should know what is right and what is wrong, and what is an advertisement and what is a requirement. Anyway, not to digress from the topic, UVC. So UVC, just know that natural source completely absorbed by the ozone layer. There are man-made sources like the welding torches or mercury lamps or UV lightings, etc. And we have to protect ourselves against any kind of exposure uh, to ultraviolet C. Then comes ultraviolet B, which is in the range between 280 to 315 nanometers. Now, in this case, what we see is that majority of UVB also gets completely absorbed by the ozone layer, but a small portion, almost 5% of it, is able to penetrate through, the ozone layer, and it is able to reach the surface of the earth. And that's why they can actually be harmful for us, especially for the top layer of our skin. It can be harmful for the layer of the skin, and it can lead to aging of the skin over time. Then we have ultraviolet A. So ultraviolet A is between 315 to 380 nanometers. Here what we see is that this is the longest wavelength, is easier to penetrate through the ozone layer, and hence it will be able to reach majority of it, more than 95% of it will be able to reach the earth's surface, and hence we get exposed to it. This is something that can penetrate through the top layer of the skin as well and reach the insides of the skin, and can cause various problems. So can cause skin aging, it can also cause wrinkles, and it has also been linked to cancer. That if somebody is really overexposed to uh, ultraviolet A, then there are chances that uh, they can develop even skin cancer in certain cases. Tanning, etc., also can happen because of this. So these are the types of ultraviolet rays. Then after that we have the X-rays. So in case of X-rays, the frequency is between 3 into 10 to the power of 16 hertz to 10 to the power of 18 hertz, and the wavelength between 10 nanometers to 100 picometers. Now we divide this into soft X-rays and hard X-rays. Now soft X-rays basically have the a longer range. Compared to that, you have the hard X-rays, which share their electromagnetic spectrum with the gamma rays. So gamma rays will have frequencies greater than 10 to the power of 18 hertz and wavelength less than 100 picometer. And this is the same range. So hard X-rays also have the same range. All right. So that's what we see with gamma rays. Now, in case of gamma rays, obviously gamma rays will be very harmful. Same goes for even X-rays. That X-rays also will be very harmful because they have very high frequency, and that's why they have very high energy. That's why we need to be protected against these X-rays and gamma rays especially. All right. So these are the different types of rays. Just remember these basics: wavelength, frequency, and the use. So for example, in case of gamma rays, we had discussed already that controlled radiations can be used in the food industry, in agriculture, even in the medical field. In all these cases, we can make the use of gamma rays. And then in case of X-rays, we know that X-rays are used for imaging. For example, imaging of the bone in terms of, let's say somebody has been through an accident and bone fracture has been uh, suspected, then X-ray images are taken so that anything that has happened with the bone can actually be found. So this is how we look at all these different types of waves. It's 7:45. Let's take a break here. Let's take a break, and if you have any questions, please post your questions. When we come back from the break, I'll take all your questions, and then after that we shall start discussing all the various different types of wireless communication. So let's be back by 8. Let's be back by 8, and let's start or restart our discussion. Welcome back, everyone. Let me first start with your questions. How do we check these TDS levels? To check for the TDS levels, the only thing, there is a TDS meter that comes, and that is able to tell you the exact nature of the dissolved solids. We use RO even if it is not required. That actually is true. A lot of RO sales is also related to the kind of advertisements that have been happening over the years, and in a manner subconsciously it has been fed to our minds that if you don't have RO filters, then you are drinking poor quality water or you're drinking undrinkable water. That's not really the case always. It depends on where you live and what kind of water supply you get, and those things actually determine whether or not you need an RO filter or not. So very frankly, the kind of water supply that I get, I do not really need an RO supply, RO water filter. Even a normal candle filter can work for me, or just a UV filter can work for me. That's enough for the kind of water that I get. Shouldn't shorter UV rays, owing to their energy, must be able to surpass the ozone layer instead of the longer wavelength, low energy UV rays? Wonderful question. But I'll tell you what, uh, when it comes to the UV interaction with ozone, what happens is that UV rays, when they reach the ozone layer, they would interact with ozone, and this is what basically can also cause the splitting of ozone into oxygen atom and oxygen molecule. That O3 will basically, we'll see that O3 will split into O2 and O. This kind of a split happens. Now, when we look at this kind of a split, what we basically also see is that this will happen only if the energy of the UV rays are high. If the UV ray energy is not high, then this UV rays cannot do anything with that ozone, and they would simply pass through. They would be absorbed and they would be passed through. So that's why in case of UVA, because it has the least amount of energy, it simply passes through the ozone layer without having any interaction with the ozone. Whereas with UVB, they have little higher energy, so that's why they interact and they also get absorbed. And UVC, having the highest one, they also get absorbed there. So that's why in case of UVC, uh, this absorption that happens, this is also called as photo dissociation. This is also called as photo dissociation. So photo dissociation meaning that ozone basically splits into oxygen atom and oxygen molecules because of UVC. So that is basically photo dissociation, that UVC breaks ozone bonds. All right. So this is basically what happens. I hope this clears your question. What are the applications of hard and soft X-rays? Basically, both of them actually can be used for medical imaging, most importantly. Then apart from that, we see that analysis of different materials, etc., can also be done with the help of hard X-rays, and same goes for even soft X-rays, but hard X-rays are more used for material analysis than in case of soft X-rays. And even in spectroscopy also, we see that they can be actually used. Right, so let's move forward. CFC plus O3 equal to O2 plus O. That's correct. That's the thing that happens because of chlorofluorocarbons. Yeah. So Nowadays we produce hydrogen by splitting water molecules. Can't we do the same with carbon dioxide molecules, capture carbon and produce oxygen? uh, Very difficult to do. It's very, very difficult to break that bond. Carbon dioxide molecules are very, very stable molecules, and that's why they cannot be split so easily. Even in the splitting of water that you are talking about, that also happens in very extreme conditions. I mean, it very, you can say, specific conditions, and it's also a process that's not very easy. But we are doing that anyway because we need that hydrogen so that we can get hydrogen to be used as fuel or for any energy source. Splitting of carbon dioxide would also need a lot of effort, but that effort perhaps will not be worth it because there are easier methods to take care of carbon dioxide than doing the split. No previous year questions, they will come, just wait. There are a lot of previous year questions that will start coming in this section. All right. So coming to wireless communication, the first one is Bluetooth. Now in case of Bluetooth, what we see is that we know that this is a short range communication, can be established for uh, a range that is normally less than 10 meters in range. It can be little more than 10 meters also, depends on what kind of area you have. If you have wide open spaces, then in that case the range can be little longer. It can go maximum maybe up to 15-20 meters, that's it. In case you have closed spaces, you have a lot of rooms, then the range decreases. But can it travel within walls? I mean, between walls, between the rooms, can it travel? Let's say if I am trying to transfer a file through Bluetooth from one room to another, is it possible? Yes, it is possible. As most of you have said, it is possible. So it is not something that will be bound by the walls of a room. It can travel between the rooms as well. Just that if you have a lot of obstacles, the ranges start to decrease. But it's not that it cannot pass through the obstacles. It can pass through the obstacles as well. Now, in case of Bluetooth devices, what we basically see is that they work on ultra high frequency radio waves, meaning that they are working on the radio waves which have higher frequency and lower wavelength. And now in this case, one thing that is worth noting is that it operates on something called as frequency hopping spread spectrum. The basic technology that works behind the scenes in Bluetooth is called as frequency hopping spread spectrum, and the operational frequency is 2.4 gigahertz. Now, when it comes to frequency hopping spread spectrum, just know about this, that frequency hopping spread spectrum is a specific mechanism that also makes this Bluetooth transfer or Bluetooth communication very secure. Specifically, when it comes to spread spectrum communication, spread spectrum communication is a specific branch in digital communication which also helps you in establishing communication with a high level of security. So that's why we see that in defense communication, in military communication, very often spread spectrum communication is used there. So that's why spread spectrum communication becomes very, very crucial. So frequency hopping spread spectrum is something that we use here to make the things more secured. Now, why do we call it as frequency hopping spread spectrum? Basically, what happens is that let's say there is a file that you are sending. Suppose that there is a 5 MB file that you want to send. There's a PDF. Suppose that the class notes, you have the class notes in form of a PDF which is of 5 MB. Just consider this, all right? So now what we see is that if we look at a graph of time versus frequency, so frequency is 2.4 gigahertz. So what we see is that the range is between 2.4 gigahertz to up to 2.48 gigahertz, like this. And this part basically is divided into 80 units. This is divided into 80 units. Between 2.4 to 2.48, there are 80 units into which it is divided. So let's say if I just divide it into not 80 but let's say 8, right? So suppose that this is the range, and I'm looking at it versus time. So let's say that this is the time interval, All right, so let's say this is time intervals in terms of seconds, and the other hand you have frequency in gigahertz, frequency in frequency in gigahertz, and this is where it has been divided into 80 units between 2.4 to 2.48. All right, so now let's say in this particular scenario what happens is you have a 5 MB file. Suppose that I am sending a 5 MB file through this. Now what happens is that this 5 MB file will be divided into packets of data, smaller units of data. So maybe 1 MB each. There are 5 such files that now it has been divided into. Now what happens here next is that what we see is that, for example, let's say if you see any kind of file transfer, you'll see that percentages will show that 10% is done, 15% is done, 25% is done, and so on, correct? Whenever you do any kind of digital transfer, you might see something like this. So why this percentage is shown is because there are packets of data into which it gets divided into, and then the transmission of the data happens. All right, so here also something similar, that if you have a 5 MB data, suppose it gets divided into 5 parts. It might get into divided into 50 parts. I'm not telling you the exact number. I'm saying that just imagine that 5 MB file, it is getting divided into 5 parts of 1 MB each. Now, what we see is that in this particular scenario, there are these 5 parts that it gets divided into. Suppose that this is one part. I'm just coloring them in 5 different colors. So suppose that these are the five parts. All right, these are the 5 parts. Now what happens is that one by one all these parts will start going. All right, one by one we will see that one by one all these parts. I'll not use yellow because that's already yellow. All right, so let's say these are the 5 parts. So now what happens is that one by one all these packets of data will start traveling. So suppose that this black colored one, it will start first. Now what happens is that it will keep on jumping the frequency. So from one frequency here, it goes to this part of the spectrum. Then from here on, it might jump to this part. From here on, maybe it jumps to this part, and so on. Similarly, then the next part, the orange colored one, maybe it starts from here. From here on, maybe it goes here. Then from here on, maybe it goes here. From here on, maybe it goes here, and so on. So in this manner, what will happen is that one by one, each of these 5 parts, they will start to jump between the frequencies, and they will keep traveling like this. All right. And now, on the other hand, they will start getting collected. So they will start getting collected on the other hand. So they have been transmitted, and now what happens? First the black part will appear here, then after that the orange part will appear here, then after that the pink part will appear here. So we'll see that one by one, then the blue one, and then the green one. So in this manner, one by one, all these will travel through these frequency ranges, and they will appear on the other side. All right, they'll appear on the other side. So in this manner, what is happening is that there is a spread spectrum, right? There is a spectrum of frequencies into which it is spread, and there is a frequency hopping that is happening. Hopping means what? To jump. So jumping of frequency is happening. So that's why what happens is that it becomes very, very difficult for somebody to hack into this system, because you do not know from what frequency to what frequency the packets of data are jumping, and that too it's just a part of the data and it's not the entire data traveling at once. So that is called as frequency hopping spread spectrum. And this frequency hopping spread spectrum, this is basically the example of frequency hopping spread spectrum. And this frequency hopping spread spectrum basically secures the data, secures the transfer of any kind of data. Now what I'm representing here is very, very watered down version of what actually goes behind the scene and what actually happens. uh, because I mean, spread spectrum, I don't know, do we have any electronics engineer here? Anyone who's from electronics and communication branch? Do we have anyone? Or nobody will say right now that you are from electronics? Right, because if you are, why I asked this question is that if you are, then you would know that spread spectrum communication is an entire subject. It's not just a topic that you learn as a part of uh, uh, electronics and communication engineering. It becomes an entire subject that many people would learn. So that's why what we are discussing here, it's just a very basic watered down version of what happens. So with the help of frequency hopping spread spectrum, we make Bluetooth very secured. Then after this, we have near field communication. Now, in case of near field communication, if you look at the range is very, very less than 10 centimeters. In largely, we'll see that uh, normally it's just 3 to 4 centimeters. All right. Normally, it is just 3 to 4 centimeters. Maximum, it can be 10 centimeters. In case of Bluetooth, we are saying 10 meters. But here we are saying just 10 centimeters, nothing beyond 10 centimeters. So that's why we see that this is basically what happens. Operating frequency is 13.56 megahertz. Now this is a very close range communication, very short range communication, that the devices almost have to touch one another, then only the communication can be established. So you'll see that in many cases. For example, uh, uh, the cards that we use, for example biometrics card or metro card, or maybe in the offices the cards that you use, they can work on NFC. Similarly, online payments that we do, the payments that we do with the help of our ATM debit or credit card, that can be done with the help of that is also utilizing near field communication. So that's why we see that near field communication can be used, especially when it comes to, let's say, making a payment. We can also encrypt it further so that the leakage of information does not happen. So that's why all these can be seen with regards to near field communication. Look at this question. This was asked in your paper. Why engineers are shy to say that they are engineers? There's a very deep rooted reason for that. So if you've read the question, I'll launch the poll for you. Please mark your answers. What is the role of wearable technologies like smartwatches, digital bands? Role, I mean, they're just making your life easier. Can't really say something about the role. There are a lot of things that are made easy because of them. All right, so poll results, 54% of you have marked the correct answer. 23% of you have marked D. It means that you're not focusing in the classroom. With reference to near field communication technology, which of the above statements is or are correct? First, it is a contactless communication technology that uses electromagnetic radio fields. This is fine. Contactless meaning wireless communication. So this is fine. Electromagnetic radio fields. So we know that radio waves are being used. So one definitely correct. Two is NFC is designed for use by devices which can be at a distance of even a meter. How can it be even a meter? I'm saying that this is such a small range communication, just 3 to 4 centimeters. Then how is it possible that it is at even a meter? This is completely wrong. So that's why 1, 2, and 3 should never have been marked. NFC can use encryption while sending sensitive information. We discussed that especially in case of the digital payments. In case of the digital payments, we basically make the use of NFC. So that's a 1 and 3. Correct answer will be 1 and 3 only. Then we have radio field frequency identification, or RFID. Now in case of RFID, the mode of its working is very similar to NFC, but the range is greater. Range is much better. Range can go up to 100 meters. Range can go up to 100 meters. Now, in case of radio frequency identification or RFID, it makes the job much easier. So, for example, let's say in a library, there is an NFC technology being used and there is an RFID technology being used. With the help of NFC, we'll be able to get with the help of NFC, what we'll see is that even if you have to, let's say, look at whether all the books are present in their required locations, or you just have to audit about all the books being present, you'll have to go to each and every book. If you are using NFC, you'll have to go to each and every book and take the information about that book to identify whether everything is fine. In case of RFID, you don't need to do that. You can simply stand at one place and you can just scan the entire library. You can scan the entire 100 meters range without any problem. So that's why RFID becomes very easy to use and very fast to use. At the same time, there are various aspects of RFID. So, for example, we see that hundreds of tags can be read in just seconds. And in case of RFID, what we see is that it can read the information with the help of a reader. So there is a very common example. There is a very popular example today in India where RFID is being used. Any idea what example I'm talking about? Where do we use it? Yes, Samajit, you are correct. Yes, Ashish, correct. So a lot of you are giving correct answers. That's great. Yes, even in covered system, as some of you have mentioned, that's correct. Hmm. So FASTag is that example that I was looking for. You might have heard of FASTag. So FASTag, that is available at tolls, where at the toll plaza your payment can be directly, the toll can be taken directly without you having to do all the hustle of exchanging the money. You have a tag in your car, and the reader is there at the toll plaza. The reader will be able to read this tag, right? So this reader will be connected to RFID reader will be connected to an antenna, and through the antenna we see that this kind of communication between the tag and the antenna happens, and the antenna will be able to fetch the information from the tag, pass it on to the RFID reader, and through the reader to the database, and database will be able to take the data or collect the money and let the car pass through. So that is where we see that in case of FASTag, we are able to actually make the use of RFID. Similarly, in various other places also we see that RFID can be used. Wherever there is a kind of a one-way communication, where there is a reader from where there is a tag from where the reader has to read the information, we see that RFID can be used there. Then after this, we have a very important piece of technology, that is Wi-Fi. Now, when it comes to Wi-Fi, understand the importance of Wi-Fi, because today we see that almost everywhere we are probably using Wi-Fi. Many of you, perhaps right now, for this classroom, you are probably using Wi-Fi network in your home. So, Wi-Fi operating frequency 2.4 to 5, 2.4 and 5.2 gigahertz. Now, in case of Wi-Fi, what we have seen is that this is a technology that has become very popular over the years. It started with 802.11a, where a wireless transmission of internet could be done for the first time, which was very unique then. Then 11b, 11g, these were where only one or two devices could be connected, nothing beyond that. And the speed of the internet also through Wi-Fi was very low. But then in case of 802.11n, which was later renamed as Wi-Fi 4, this was renamed as Wi-Fi 4 because now it had started becoming popular. Now number of devices being connected were higher. The speed that you could fetch with the help of this Wi-Fi was also better. So now it started to become popular as something that would be used in certain areas like offices, etc. So Wi-Fi 4 became so that's why it was renamed as Wi-Fi 4 for the sake of simplicity, because now people at large had started using Wi-Fi 4. So that's why it was renamed, and subsequently these were named as 3, 2 and 1. Now after this, currently we are largely at Wi-Fi 5. Right now this is what we are using. This is what we are using right now, where you could very easily connect to 6 to 8 devices without losing the speed, and the speeds are decent. And today in the offices, in our homes, everywhere, Wi-Fi is probably being used. A lot of us are now using Wi-Fi. Then comes the next technology which is about to be released, and this is Wi-Fi 6. So from your current affairs perspective, this is very, very important. From current affairs perspective, Wi-Fi 6 is important. Now with Wi-Fi 6, it is being promised that the speeds will be even better, and the number of devices that you could connect to without losing the speed will be much higher. Because now today this is what we see, that every household has a good number of devices that perhaps can connect to Wi-Fi. So for example, let's say if you have a family of 4 people, but at least there are 4 mobile phones, if not 6, if not 8. So at least there are 4 mobile phones, then probably there are 2 3 laptops, then maybe your TV also connects to the Wi-Fi. Maybe you have wearables or smartwatches, etc., that can also connect to Wi-Fi. Maybe you have a washing machine and a fridge that can also connect to Wi-Fi. So now we see that the number of Wi-Fi devices in each and every household has been starting to increase, and with that, Wi-Fi 5 cannot really handle that very efficiently. So this is where we move to the next stage, where we see that uh, much better speeds, much lower uh, number of problems, much better security, all these things. And even when it comes to the various aspects of the number of devices, etc., we see that in all these cases, we already see that Wi-Fi 6 is being used. So Wi-Fi 6 will provide a much better service as compared to Wi-Fi 5. Already, it's not that it's in the future. Already we see that there are some devices which have started using Wi-Fi 6. There are some countries which have started rolling out Wi-Fi 6, and very soon we'll see that it will start replacing Wi-Fi 5 in a much greater way. So when it comes to Wi-Fi 6, there are two technologies on which it works, what makes it very advantageous. So first, let me tell you about the advantages. What are the advantages that Wi-Fi 6 would have, because of which we are talking about Wi-Fi 6 so much? First and foremost, it will be faster. It will give you much better speed as compared to the speed that we are getting until now with Wi-Fi 5. And then we talk about lesser latency. Now, when we say latency, latency basically is a lag in the network. Latency is something called as the lag in the network. Now, anyone who recognizes what this image is of, what this image, where have I taken this image from? Yes, BGMI, or popularly called as PUBG. So now, those of you who have played PUBG, first I'll give you an example which is relevant to you, and then I'll give you an example for others as well. So for those of you who have played PUBG, you might see that there is this number that is there on the bottom of your screen, correct? A 2 digit number or a 3 digit number. So if this number is very high, let's say this number is 300 or 400, you say that the ping rate is high, correct? You use this term, ping rate. You'll say that the ping is high or the ping rate is high. So when ping rate is high, you'll say that you are not able to play well, correct? Because this number that you have, let's say the number is 400, so that means that this is 400 milliseconds. This is in terms of milliseconds. So that 400 number means that there is a lag of 400 milliseconds in your network because of some reason. Maybe your device is not doing that great, maybe because of the internet connectivity not being that great. There could be a number of reasons. For any reason, when the ping rate is high, it uh, it means that you are lagging behind, and it gives you an excuse to play badly. You can say that my ping rate was bad, that's why I'm not was high, that's why I'm not able to play well, correct? And if the ping rate is very low, then in that case you will have a very good experience in playing that game. So this is what we mean by latency. This is what latency is, that if the latency is high, then your experience is bad. If the latency is low, then your experience is good, because you are then connected with others on a real time basis. Same happens everywhere. For example, in case of offices, also there might be a central server, and then all the office laptops or all the office systems might be connected to this central server, and they are getting and receiving and transmitting the information from the central server. So maybe because of internet connectivity issues, or maybe the device not being that good, maybe because of these issues, some of these devices may not be able to interact with the central server on a real time basis. So that also will be because of higher latency. Then even if you watch news, many times what you'll see is that if there is a ground reporting, live ground reporting happening, when whatever that reporter says, the person who's sitting in the studio will hear the same thing 5 seconds later, right? They'll wait for like 2 3 seconds or maybe 5 seconds, and then you will see that happening, that they are receiving that information a little later. So that also is happening because of the latency. So we see that there are multiple different ways. I mean, even in this live class, if let's say you were sitting right beside the studio, you would see that the studio voice would come just a second or maybe 2 seconds earlier than the voice, or let's say the transmission that you get on your laptop or your tablet or your mobile phone. So that also is a little lag that happens because of the transmission and the reception of the information. So that is called as lag. Lesser the lag, the better it is for us, right? Lesser the lag, it means that we are actually live, or we are able to uh, transmit and receive the information on a real time basis. So that's why that also becomes one of the advantages, that it will have very low latency. Then it will be able to provide a better security. This is something that is also being implemented as a part of Wi-Fi 6, and it would also help in improving the battery life. It will have a better power efficiency as compared to Wi-Fi 6, sorry, Wi-Fi 5. One more, if I add, more number of connected or simultaneously connected devices. It could connect to more than 30 devices. It would be able to connect to at the same time. So that's why we see that in all these cases, this is how we see that Wi-Fi 6 will be very, very advantageous. Now try to understand what works behind the scenes, that what makes Wi-Fi 6 so special. There are two key technologies that we are using here. One is called as OFDMA, and the other one is called as MU-MIMO. So what is OFDMA first? So OFDMA orthogonal stands for orthogonal frequency division multiple access. Orthogonal frequency division multiple access. Now what does this OFDMA do? Now this OFDMA, it becomes very, very crucial piece of technology here, because with this OFDMA we'll be able to increase the efficiency. We'll be able to increase the efficiency, and thus it will be able to reduce the latency. So latency reduction that happens, it happens because of OFDMA. Now how exactly that happens? Just try to understand this. Right. So for example, let's say suppose that you have a Wi-Fi connection, and there are three devices that are connected to your Wi-Fi device. There is one laptop. Suppose that you are using a laptop where you are watching this lecture. Let's say somebody else in your home is connected with their mobile phones, and they are watching, let's say, a film on an OTT platform. Let's say there is a third device, third person also connected. Maybe the television is connected, and they're let's say listening to a song there. So let's say there are these three different transmissions happening at the same time. So then what happens is that all these three will be sent via three different packets of data. So there will be three different packets of data, but these packets of data, they are not completely occupied. Only one part of the data packet is occupied at once. So it's not the entire data packet that is being used. So then what happens is that these all will go and interact with the Wi-Fi device one by one. So it this goes, then after that maybe uh, let's say this goes first, and then this goes, and then the first one goes. So one by one they are interacting. So then in that case it takes more time, right? It takes more time. So that's why the efficiency is not that great. Efficiency is not going to be good enough. Now if we want to increase the efficiency, what is an alternate? How can we increase the efficiency? Let's say the same packet of data, let's say the same packet of data was able to transmit everything. Let's say all these three packets of data at the same time could be transmitted like this. So instead of three different packets going into the Wi-Fi device or trying to connect with the Wi-Fi device, there was only one packet of data that could do that job. So then in that case it will be highly efficient, correct? So just imagine, let's say you Amazon, you have an Amazon or a Flipkart, something like any e-commerce, uh, any e-commerce company. Let's say when they have to send the parcels to three different parts of a city, they have three different trucks for that, and only small parcel or small piece of parcel is being sent in each and every one of these trucks. Then in that case it's not efficient, correct? Instead, if let's say one truck was able to carry all these three pieces of parcel together, then in that case it will have a better efficiency. So something similar is what we are doing here, that instead of having three different trucks to carry three different data, we are having one single truck to carry all the three data. That is what is happening in case of OFDMA, and hence OFDMA is able to increase the efficiency, and thus it is able to decrease the or reduce the latency in the network. Then the other technology that works here is MU-MIMO, that is multi-user multi-user multiple input multiple output. All right, multi-user multiple input multi output, that is what it means. So here what we see is that this system will increase the capacity, and thus it will help in having a higher speed per user. Now what happens in this case is that now what we are doing is that we are trying to make the operations faster. How are we exactly doing that? Now let's say for example, uh, there was, let's say there is something that we need to send from Delhi to Mumbai to Bangalore, and maybe also to Kolkata. All right, so then what happens is, suppose that there is a truck that is completely loaded and it goes to first Mumbai, then it goes to Bangalore, then it goes to Kolkata. Instead, what if I had three different trucks, one completely loaded for Mumbai, one completely loaded for Bangalore, one completely loaded for Kolkata. If I could do this, if I could do this, that all these things, all these three parcels could be sent simultaneously, completely loaded, because loading has been done completely because of OFDMA, and now we are sending it separately to different locations. That every parcel of one location of a city through one truck, every parcel of second location of a city through second truck, every parcel of third location through the third truck. So in this manner the speed will be faster, the speed of delivery will be faster. So something similar happens in MIMO system, that here we see that it will be able to increase the capacity that you can carry through the given bandwidth, and hence it will increase the speed of operation. So that's why we see that in these two cases, one being orthogonal frequency division multiple access, and the second one being multi-user multiple input multiple output. These two systems together, they are providing all those advancements to Wi-Fi 6 that makes it so efficient. So that's why Wi-Fi 6, these two become very key technologies. Look at this question, this was also asked in your paper. I'm launching the poll for you. Please mark your answers. Hmm. So almost distributed. 36% of you have marked A, 11% B, 19% C, and 33% D. Hmm. So one thing that should have been avoided is C. I can understand the confusion between A, B, and D, but C was an easy to strike out option. I'll tell you why. So question says, what is the difference between Bluetooth and Wi-Fi devices? First says Bluetooth uses 2.4 gigahertz radio frequency band, whereas Wi-Fi can use 2.4 or 5 gigahertz. So this is true. We discussed that the operating frequency of Bluetooth is 2.4, and for Wi-Fi it can be 2.4 or 5.2. So 5.2 or 5, you can say that this is fine. So A is correct. B is Bluetooth is used for wireless local area networks only, whereas Wi-Fi is used for wireless wide area network only. So now when it comes to these network areas, there are four types. There is personal area network, there is local area network, there is wide area network, and then there is metropolitan area network. All right, these are the four different types of networks. Now when it comes to personal area network, this is in the personal space, so you can say within a room. So this is something which is within a room in most of the cases. Then in case of LAN, it could be within, maximum maybe within a building. This could be within a locality, and this could be within a city, the entire city. Now look at this option. Bluetooth is used for wireless local area network only. Could this be correct? This is wrong, because maximum you normally you'll basically use it in personal area network, right? You'll largely use it in personal area network and maybe local area network. So saying only is wrong. Wireless area Wi-Fi will be used in personal area network also, correct? This will be used in personal area network and will be used in local area network also. Within a locality is a very big segment too for Wi-Fi to work. So that's why this is also wrong. So B is wrong. So if B is wrong, D is gone anyway. C is when information is transmitted between two devices using Bluetooth technology, the devices have to be in the line of sight of each other. Don't, we discussed this, if you remember, that they can travel within the walls, they can travel from one room to another. So Bluetooth communication can be established between two rooms. So line of sight, being in the straight line or having to see that device is not always required. So that's why this is wrong. Have to be in the right line of sight is wrong. Whereas when Wi-Fi technology is used, the devices need not be in the line of sight. This is fine, correct? So that's why this statement is also wrong. So correct answer will be A. Then we have Li-Fi. Now Li-Fi basically stands for light fidelity. Light fidelity. Now this is where we are transmitting the data via light. What kind of light? We usually will be using some kind of LED. We'll be using some kind of LED. Now as you can see here, it is very fast. It is almost 100 times faster than Wi-Fi. Speeds can go up to 224 gigabits per second, which is again very extreme speed. It can, because light waves are used, so 380 to 780 nanometers cannot pass through walls. This is very important, that it cannot pass through walls. because light cannot pass through walls. For example, whatever, let's say tube light or bulb or LED light you have in one room, do you also see the light of the same in the other room if there is a wall in between? No, you use another bulb or you use another tube light in the other room, correct? Because light cannot pass through walls. Understood? Light cannot pass through walls. So because of that, Li-Fi signals can also not pass through walls. And also security wise, we see that it is more secure. Now the question is, where do we use Li-Fi? Li-Fi becomes especially useful whenever you are trying to avoid any kind of electromagnetic interference. To used when we want to avoid any electromagnetic interference any electromagnetic interference with specially radio waves. So let me give you an example. Suppose you are in a flight, in an aircraft. So what happens there? Let's say you are flying from one city to another. You'll be asked to keep your mobile phones either switched off or in an airplane mode or flight mode. Correct? You'll always be asked to do that. Why? Because as soon as you put your phone on flight mode or airplane mode, all the radio signals that will be transmitted by your mobile phone, they are all blocked. So now your mobile phone does not transmit or receive any radio signal. Why do we need to do that? Because the pilots will be using radio waves for communicating with the earth every second. So their communication can be hampered. There is a chance, although very slight chance, it may not happen, but there is a very slight chance that somebody's radio frequency or somebody mobile phone radio frequency comes in the way of the radio transmission or radio communication of the pilots. To avoid that kind of a scenario, to ensure the safety of the flight, the passengers would be asked to put the phone in the flight mode or airplane mode. Now, when you are in the airplane mode, this is where, let's say, if the flight wanted to give you the internet connection, they wanted to give you a Wi-Fi connection. So then they can give you the Wi-Fi connection with the help of Li-Fi. So then that's where technically it will not be a Wi-Fi, but the internet connection that can be given to you can be with the help of Li-Fi, because when rays are being used, the light waves are being used for transmitting the internet, it's not going to interfere with radio communication, because the frequency range of radio communication is completely different. Frequency range of light wave communication is completely different. So that's why there will be no electromagnetic interference between the two. All right, so in these kind of scenarios, wherever we want to avoid electromagnetic interference, we see that Li-Fi can become very, very useful for us. Look at this question, very simple question. This was asked in your 2016 paper. I'm launching the poll for you. I'm sure that many of you are going to give me the correct answer this time. Li-Fi must be expensive than Wi-Fi. Yes, it's way more expensive than Wi-Fi. Wi-Fi 6 is the feature of wireless router or the internet provided by the network provider. No, it is the feature of the Wi-Fi router, the Wi-Fi technology itself. Nothing to do with the network provider. Great. So 86% of you have given the correct answer here. So the question says, with reference to Li-Fi recently in the news, which of the following statements is or are correct? First, it uses light as the medium for high-speed data transmission. Now, just remember that there are two parts to this sentence. First part says it uses light. This is fine. And medium for high-speed data transmission. This is also fine. So, this is correct. Second is it is a wireless technology. This is also correct. It is wireless and several times faster than Wi-Fi. This is also correct. So, that's why both the statements are correct. So, correct answer will be C, both 1 and 2. Then there is this one question. This was asked in your 2020 paper. Just read the question. Sir, do you play PUBG? I will neither confirm nor deny that. All right, so I'm launching the poll for you. Yes, Hayum, you are correct. This is how we solve this question. Hmm. So 33% of you surprisingly have marked A, 17% B, 31% C, and 19% D. Let me tell you what the answer is. With reference to visible light communication, visible light communication meaning that we are using visible light just like Li-Fi. So Li-Fi can be considered as an example of visible light communication. Which of the following statements are correct? First is VLC uses electromagnetic spectrum wavelengths 375 to 780. This is correct. It is in the range of light. We are using light, so this is good. VLC is known as long range optical wireless communication. How is it long range? We discussed that the communication happens within the room. Communication would happen within the room. You are using light waves which are smaller than radio waves. So obviously very long range communication cannot happen. So this is wrong. Statement number 2 is wrong. And you have statement number 2 here, here, and here. You get the answer from right from here. So this is how actually you should mark this answer. Although there is a twist to this. Statement number 3. VLC can transmit large amounts of data faster than Bluetooth. Of course, faster than Bluetooth, because we already discussed that Li-Fi is faster than Wi-Fi. Wi-Fi anyway is faster than Bluetooth, correct? The data transmission through Bluetooth is very slow as compared to Wi-Fi, and Li-Fi is 100 times faster than Wi-Fi, so anyway faster than Bluetooth. So that's why this is fine. Statement number 4. VLC has no electromagnetic interference. Now, this is a wrong way to put this. What we discussed is that we try to avoid, right? We try to avoid this interference. Saying that this will have no interference is wrong. What if you have two Li-Fi sources in the same room? So if you have two Li-Fi sources in the same room operating at near about same frequencies, then they can interact. Then electromagnetic interference can happen between them. So in that scenario, saying that VLC has no electromagnetic interference would be wrong. So that's why, I mean, strictly speaking, the correct answer should have been 1 and 3. Strictly speaking, the answer should have been 1 and 3 only. uh, it should not have been, I mean, 4 is not correct. I think it's just that they're trying to rephrase the information they might have. I think they have misinterpreted the information. Saying that it has no electromagnetic interference is wrong. We Ideally we should say that we avoid electromagnetic interference with the help of VLC communication. But there is no 1 and 3. The closest to the correct answer is 1, 3, and 4, and that is what UPSC says, that pick the correct answer or the most appropriate answer. So the most appropriate answer here is 1, 3, and 4, but strictly correct answer should have been 1 and 3. They should have avoided this thing. And this is what I told you. If you remember, in nanotechnology also we discussed this. 2020 paper exceptionally was odd, because they had all these kind of vague questions that they gave in 2020 paper, kind of questions that they should have never asked, because you do not know, you are asking a generalist paper and not a very scientifically accurate paper. Now coming to 5G. Now, in case of 5G, when we say that today we are in the 5G, what do we mean by 5G? 5G means fifth generation. So if we say that today we are in the fifth generation, it means that there have been four generations before this, correct? So the first generation of mobile network was where it supported only voice. It supported only voice, and that is the reason it that is where we started talking on the mobile phone. All right, this is where we started talking on the mobile phone, and no internet, nothing else, just the mobile phone. So it could support only voice and nothing else. The speed being between 2.4 to 14.4 kbps. Then comes 2G. With 2G, for the first time, we see that now voice and data both are supported, meaning that now you could use internet on your mobile phone. The speed now goes up to 50 kbps. So internet on the mobile phone, a big thing for everyone who could use it. I'm not sure how many of you know about this 2G era. This was a big thing for us, that at least now we could use internet on the mobile phone. That itself was big. Forget about the speed, forget about what kind of services you are getting. Just having that mobile phone internet was enough, and the speed was very slow. I mean, even if you are doing a basic Google search, you type whatever what website you're going through or whatever you're searching on Google, you type that, go have your lunch, come back. By that time the website would have loaded. So it would take a lot of time, but at least it was a privilege. I mean, I would still say that it was a privilege to have that your mobile phone could now use internet. Then comes 3G. In 3G we see that there is a significant improvement in the speed, of course supports both voice and data. Then comes 4G, and this is where we are largely right now. Although 5G now has been introduced, and penetration of 5G also has been increasing, but with 4G, we see that the speeds drastically improve, and something of the sort of live streaming of the data is now possible. Even with 3G, live streaming was not exactly possible, but with 4G, now we see that live streaming of data also becomes possible, and that's why it was a big change that we see in the mobile phone network. Now, in case of 4G, what we also see is that there are two technologies that are used here. First, it was LTE, and then after that, it got upgraded to Volte. Now, what is LTE? LTE basically stands for long term evolution. Long term evolution. Right? Long term evolution. And Volte stands for voice over long term evolution. So you can say in a manner it is voice over LTE. Now the basic difference between LTE and VoLTE is that until the time of LTE, meaning 2G, entire of 3G, and up to 4G LTE, you could either talk on the phone or use the internet. You cannot do both at the same time. As soon as you dial a number or you receive a call, you'll see that internet will go, internet connection will be lost, and when you disconnect the call, then only internet connection comes back. This was LTE. With Volte, what happens now, both internet and talking on the phone can be done at the same time. That you can talk to somebody while scrolling your Instagram, you can do both at the same time. So that is what happens with Volte. So in case of Volte, what we see is that this is the change that happens, that you could use both voice and internet at the same time. Until LTE, until 4G LTE, you could either talk on the phone or use the internet. So in this particular scenario, while talking on the phone, internet gets disconnected. So this is something that we had until 4G LTE. With Volte, what we see is that voice and data can be used simultaneously. voice and data can be used simultaneously. All right, so this is what we see with 4G VoLTE, and the same basically continues in 5G as well. The speeds now are much better, correct? Speeds are much better, supports both voice and data. So coming to 5G, coming to what 5G technology is. So in 5G technology, of course, we are using radio wave frequency. And here we see that now these services have started. That today we see that last year we also officially launched 5G. And slowly and steadily the penetration in India also is increasing. Started with the bigger cities, now it is also going to the smaller cities and towns. So this is basically what we see with 5G. Now, overall estimations are that by 2025, there will be more than 88 million connections in India only with regards to 5G. Now, overall, when it comes to the working of 5G, there are some basics that you should be aware of. That how exactly do we use 5G? What do we do in using 5G? So this is a typical setup of 5G, that you have a big cell tower that we have. You might have seen that there are cell towers all across the city, the 4G and the 3G cell towers. Something similar, you'll have the big cell towers, and they will be complemented with the small cells. Now, these small cells, they become crucially important for giving you the high speed internet in case of 5G. So what now happens is that this small cell will have to be placed all across the city. The density of these small cells will have to be much higher, because in case of 3G or 2G or 4G, you might have seen that there are cell towers, and that cell tower can very easily cover 500 meters or half a kilometer and so on very easily. But these small cell towers, they can't do that. They'll only be restricted to a very small area. So suppose that you have a locality. Let's say you have a locality like this. These are the homes that you have in this locality, and the roads run parallel. Suppose that the roads are running parallel like this. Right, so we know that the roads are running parallel like this, correct? So now that the roads are running parallel like this, what happens is that suppose you have a small cell tower here. Suppose that we have a small cell tower here. So now this small cell tower that we have, it will be able to transmit in this direction, it will be able to transmit in this direction, it will be able to transmit in this direction and this direction, but not here. All right, not here. So that's why if you want connection in this house, you need another one. You need another one, maybe, which is placed here. This is placed here, so this will be able to cover this area, this area, this area, and so on. So you will need this. All right, this is required so that you do a better job with the kind of data speeds that you want to give. If the density of these cell towers, the small cell towers, is low, then in that case you will not be able to provide that kind of speed. You will not be able to provide that kind of a service. So that's something that is very, very problematic, and also that's why it increases the cost of implementing 5G. So there are certain features of 5G that we should understand, that how exactly 5G works. So first thing, higher frequency bands. We see that we have higher frequency bands being used here. So if you see, in case of 4G, we were only using this much. In case of 5G, we are using the entire band. So that's why we are using the millimeter wave frequencies as well, that allow for the faster data transfer speeds. And at the same time, we know that there is a narrow band frequency, the small band frequency also, that is being used. So both will be used at the same time. So in a manner, better frequency or larger spectrum is being provided. So what we basically see here is that we have larger spectrum being provided, leading to better speed. So it's just basically about, let's say, having a narrow road versus having a wider road. So in a narrow road, there can be traffic congestion, but in a wider road, the traffic can keep on moving very easily, right? Traffic movement will be much better when you have a wider road. So this is basically what will happen in this case also, that the speed transmissions will be faster because higher frequency bands are actually being used as well. Then we have MIMO, the same basic thing that we discussed in case of Wi-Fi 6 also, and this helps in improvement of the signal strength and also reduces the interference. So it will allow multiple antennas to be simultaneously used to transmit and and receiving the signals. So we'll see that the same MIMO technology that we were using in Wi-Fi 6, the same is being used in 5G as well. Then there is something called as network slicing. Now this network slicing also helps a lot in increasing the speed and the efficiency. So what network slicing means is, if you look at this particular picture, so what you would see is that we have provided parts of network to one kind of service. So for example, let's say the high bandwidth has been provided to the smartphones. Then for automotive you have different. For the internet of things devices it is different. So the entire 5G, there are parts of 5G that are being provided for each and every part of the system. So in this manner we see that this is something which is called as network slicing, and this network slicing will be very crucial so that you can provide seamless connectivity without any hassle, without any interference. So that's why network slicing also is a very important aspect of 5G technology. So network will be divided into virtual slices that can be customized to meet the needs of specific applications or services. Then after that, there is something called as edge computing. So features of edge computing is also used in 5G network, and this helps in reducing the latency of the network. So what is edge computing? So in case of edge computing, what happens is that let's say you have a central server. Let's say you have a central server like this, and this central server will be connected to a lot of local servers. This central server will be connected to a lot of local servers like this. So now what happens is that the last bit of information, so there are a lot of local servers that it is connected to. Now these local servers, they will be connected to multiple devices. So instead of the central server connected to every device, now you have these local servers which are connected to all the devices. So then in that case, the latency decreases because the number of connected devices are less. So the transmission of information can happen with a better efficiency and hence at a lower latency. So that's why what we see is that it helps in reducing the latency and improving the performance. So that's why this kind of a system is called as edge computing, where you have one central server connected to a lot of local servers, and all the end devices are connected to these local servers. So that also helps in improving the features of 5G. Then we have OFDMA, something that we just discussed, that it helps in transmitting simultaneously across various different frequencies. So something similar to what we discussed in Wi-Fi 6, OFDMA also is used in in 5G. So in this manner, we see that these features become useful. Then the latency here also is very low. Latency can be as low as just 1 millisecond. Latency of 5G can be as low as just 1 millisecond. So that also is a very crucial thing for 5G. And then lastly, the network densification. So in case of network densification, we see that the placement of more cells is done in a given area so that we can increase the capacity of the network. What we discussed about the small cells, what we discussed about the small cells, that is basically what is being used in case of 5G. So that's why there are all these features that we have with regards to 5G that will be very useful, that will be very useful in case of 5G network, implementing the 5G network. So this is basically how it works in case of 5G. Now, in case of India, we see that there is something which is also called as 5G I, and this 5G I is something that India has developed specifically for the Indian needs. It is something that has been developed in India for Indian needs, and it is something that is going to use. That is something which is going to help in improving the 5G coverage in the rural and the remote areas. So this is something that was jointly uh, prepared, or this is something that was done by two IITs, IIT Madras and IIT Hyderabad. So basically these two had combined, and these two had combined the forces, and they basically they have created this technology along with along with the Center for Excellence. I'm just writing it out here. Center for Center of Excellence. Center of Excellence in Wireless Technology. CEWIT. Save it. All right. So along with them, these three have combined their forces, and they basically have created this 5G. Now 5GI. Now in case of 5GI, what we see is that uh, there is the basic idea here is to provide 5G coverage, 5G coverage in rural and remote areas of the country. So this is basically why this has been done. Now overall what we see is that there is something little difference that we are using, that instead of having a lot of small cells, there is one key technology that we are using, and this is something which is called as low mobility large cell. So just remember this: low mobility large cell. This is something that is used. This is called as LMLC. This is basically used, and we see that there are uh, lower operational bands that will be able to use for 5G, and that's why we'll be able to use 5G better with the help of these cells, without compromising on the range. Without compromising on the range, we'll see that we'll be able to use them much better. So overall, that is something that we see, that how exactly that increases, because with the help of LMMC, what we see is that the range can increase. This increases the range from about 1.7 kilometers to up to 6 kilometers. All right. So this will increase that range, and that's why we'll see that they'll be able to travel a longer range, and that's why the number of devices, the network densification requirements that we have, will be at a lower range. So that's why we'll see that they will be better. They will provide uh, connectivity to the rural and the remote areas. Also, they become cost effective. They become cost effective because the infrastructure requirements basically will be lower. So that also becomes very crucial with the perspective, when it comes to the perspective of implementing 5G in India. So low band spectrum or narrow band spectrum, both will be used. Interoperability with the existing networks, meaning with 4G or 3G cell towers, that can be done, and hence localization is also possible that we have here. So that's why there are all these things that we have. Now 5GI is something, that's why it is something which is very specific to India. All right, it is something which has been specifically designed for India, and that's why there is one more problem that we are talking about here. One more problem could be that a lot of hardware that is available, the mobile phones that are available, these mobile phones have been manufactured before even 5G arrived in India. So we do not know whether they will be very easily compatible with 5G I or not. They'll be compatible with 5G definitely, but with 5G I, how compatible they will be is still to be seen. So that is what 5G I is. So from current affairs perspective, this is something which is very very important, because this is specific to India. The advantages with 5G, uh, the data speeds will be much faster, up to 10 Gbps, ultra low latency, just 1 millisecond. Then all the areas of application, whether it is internet of things, whether in agriculture, whether in various different technologies, in medical facilities, in traffic management, in all these cases we see that we will be able to use 5G. And that's why what we see is that with 5G, the mobile phone network goes just beyond the personal use. Until 4G, we could say that mobile phones were just, the 4G networks were just about our personal use. But with 5G, we see that it goes beyond just the personal use. It can be used for a wide variety of applications. So that's why these are things that we are seeing as advantages with 5G. The issues, first and foremost, high investment requirement, because you need new infrastructure, you need the small cells, and you need all these things. So that's why there are uh, infrastructure requirements. Then the spectrum is also expensive. Why am I saying this? Because you need wider spectrum, correct? It's just like buying a piece of land. Suppose you buy a smaller piece of land, you pay less for it. When you buy a larger piece of land, you pay more. This is basically what a wider frequency, or this is what a wider spectrum is. So wider spectrum means costlier, correct? So that is what we are saying. That's why it's expensive spectrum. Issue of compatibility of old devices, that is what we discussed, that the older devices, for first thing is that most of these 5G devices, they started coming in 2021. Before 2021, there were only rare few devices that were 5G compatible in India. Now many users still have mobile phones that are not 5G compatible. For example, me, I'm not 5G compatible yet. And what happens is that, let's say, if users like me or others who are not yet using 5G network, if they start using 5G, if they want to use 5G, first and foremost they have to change the device. Changing the device means what? A lot of e-waste, a lot of electronic waste will now be generated. So that is what the problem is, that is where the problem lies, that if we start looking towards this, we'll see that more of e-waste problem will start to surface. So that also becomes a challenge. And then there are potential security and privacy issues. We don't know for sure, but there are chances that these kind of issues could also be there. So that's why we have to understand all these aspects of the problems as well. One more issue has been that not a lot of enthusiasm has been shown by the consumers, because for many of the consumers 4G works well for them. Personal opinion also, 4G works well for me. Wherever I go, I have a Wi-Fi connection, whether I am in the office, whether I am at my home, wherever I am, there will be some kind of Wi-Fi connection. We are normally connected to that Wi-Fi connection. When we are outside, the 4G connection works decent enough and my requirements are being met. So until I find that no, my requirements are not being met with 4G, I have to switch to 5G, then perhaps I'll think of buying a new connection. So that also is one of the things that has been observed. The penetration rate of 5G, what was expected and projected, is not the same as what we see in reality. Now because of that, right now they are also expensive, because if you connect more users, you will become cost effective. When the number of users are limited, it will obviously be uh, costly also. So that is also one of the problems that we have right now with 5G. Look at this question, this was asked in your paper. It's an easy question. Please read the question carefully. Give me as many correct answers as possible. Let me launch the poll for you. Please mark your answers. Hmm. So 61% of you have marked the correct answer. That is D. Let me discuss this with you. With reference to communication technologies, what is or are the difference or differences between LTE and VoLTE? First is LTE is commonly marketed as 3G and VoLTE commonly marketed as advanced 3G. Nothing to do with 3G. What did we discuss? Let me go back. Yeah. So Volte and LTE. LTE is up to 4G LTE. Volte came in 4G. So there is no 3G Volte, correct? So that's why we cannot say that it is being marketed as advanced 3G, correct? We cannot say it is advanced 3G or marketed as 3G. This is completely wrong. LTE is data only technology, and Volte is voice only technology. That's also wrong because it's nothing to do with only data or only voice. In case of LTE, we are saying that if you are using voice, you can't use data. And in case of Volte, we are saying that you can use both simultaneously. That's the difference, correct? So even this is wrong. So correct answer, that's why will be D, neither one nor two. I know whenever you have a neither one nor two kind of question, our brain starts to tell us that at least one of the two statements should be correct. How is it possible that both of the statements are wrong? So we tend to go by that logic, and we many a times also mark a wrong answer. But always remember that whenever you get a question, just mark the answer based on the merit of the question and forget about everything else. Right? So let's halt our class here. The next topic for us is Internet of Things, which will start in our Monday's class. So half of this chapter is left. Almost, let's say, 1.5 hours it will take for me to complete this chapter, and then after that, the last chapter of intellectual property rights is what we'll discuss in our next class on Monday. So meanwhile, if you have any question, please let me know. Let's discuss your doubts and queries, and then after that we shall end the class. Remember that on Tuesday we also have a doubt class. So if you have any doubts with regards to those classes or all these things that we have discussed, please send us an email with all the doubts that you have, with a subject doubt underscore science and technology, something like this. Please do that so that we can also recognize that that's a doubt. The leaderboard for the day, this is the leaderboard. I'm showing the leaderboard now. Yeah. Can we use satellites instead of mobile towers for mobile network connection? No, satellites are connected to the mobile towers. The communication that is being established, communication is being established with the help of your satellites. All right. So that's why satellites obviously are involved. You have all these communication satellites, and all these communication satellites will help you in communicating through the mobile phone towers. Sorry. So this is up to 7, and this is after 7. Okay, sorry. So all of you have are rank 7. How is data, that is audio, text, or video, converted into waves and later data again? So what basically happens is that it's not always so when you talk about data, this data is audio. I mean, the data is waves. Basically, the transmission is happening as pockets of data. So these packets of data are nothing but waves in a manner, you can say. Now, whether you say audio or text or video, the transmission happens as waves. All right, the transmission happens as waves, and then after that, it is transmitted. So this wave is a carrier. This wave becomes a carrier of the information. carrier of the packet of that data. I know many of you in the VLC communication statement, you thought correctly that the fourth statement was a extreme statement that they had given, but unfortunately, this is how life is sometimes. So you were correct in your logic. UPSC was not, but unfortunately, this is what they have given as the official answer. Also, sir, when we have all the correct options, that time we think at least one should be incorrect. Yeah, that is how basic psychology works. That we think that they are smarter than they actually are. So that's why always take the statement on its merit rather than anything else, because it is so much already has been fed to our minds that this is the toughest examination in the world, at least toughest in India. Some people, to make it believable, they say that this is the second toughest examination in the world. How do you gauge that toughness? There's no way to gauge that toughness. You can't say that this is tough and that is not. So for example, let's say, for example, if somebody tells you that UPSC civil services is a tough examination and SSC is an easy examination, I don't agree with that. I'll tell you why. In UPSC prelims examination, there are like 5 lakh people who are appearing, and that too, out of that, there are 50,000 students or maybe 1 lakh students who are really really prepared for the examination. In SSC examinations, there are 25-30 lakh people sitting, aspirants sitting, and out of them, at least there are 5 lakh people who have really really prepared for it. So look at the competition that you have there. So that's why sometimes not the level of the question paper, but the competition of the paper makes it very very tough. So that's why you can't say that this is tough, that is tough. You have a syllabus, you have the previous year papers. Just go by the merit of each and everything and forget about what is tough and what is not. Internet of things we'll discuss in the next class. That's why I've not explained it here now. Update the PPTs of previous classes in exam prepper. I'll check with the team. I'll ask them to do it. If Lagrange point move with Earth, it is it the same as HEO satellite? No, it is not the same as HEO satellite, because the path is very different. The path is very different because it's a, so HEO satellite is revolving around the Earth, right? It is revolving around the Earth, whereas Lagrange point is moving with the Earth, correct? Lagrange point moving with the Earth, HEO satellite revolving around the Earth. Understand the difference? Does Starlink need a tower? No, it will be directly satellite based. When these electromagnetic waves are everywhere, uh, emanating from various devices, how are they correctly captured? So basically, every device is made in a manner that they can only capture a certain part of the electromagnetic spectrum. So for example, your mobile phone, let's say for this mobile phone has a uh, this has an antenna inside the mobile phone. You have an antenna, and this antenna that we have inside the mobile phone, this will capture only the radio frequencies with regards to that 4G. So only the 4G band is what it can receive, others it will not. So even if there are all these electromagnetic waves around, it will only receive the ones that are being transmitted by the particular band. In SSC MTS, for 12,000 ports, 52.5 lakh applicants. That actually is what I was saying, that because of that kind of competition, it really makes it very very difficult examination. That you have to, I mean, score like 90% in that paper to get through. And in your civil services examination, you will have to be around 40-45% to get through the prelims. So somebody who has not prepared for who hasn't been preparing for civil services and only for SSC will tell you that you are writing an easier examination. You just have to get 45% marks, and I have to get 90% marks to get through. So it's perspective, everybody's perspective. What is bandwidth and how do its implications change with the increase of bandwidth? So bandwidth, when we say bandwidth, means how much of frequency are you using. So bandwidth is that range of frequency, that let's say 1 hertz to 10 hertz is a smaller bandwidth, 1 hertz to 100 hertz is a larger bandwidth. So that is what we mean by bandwidth. Larger the bandwidth, the better will be communication, the better will be the efficiency. So that is what we see here. How can someone purchase the spectrum? So purchasing the spectrum is for the telecommunication companies. That the spectrum, there is the band of frequencies, all right. So in this band there is something called as Ka band, Ku band, X band, M band, and so on. So there are all these bands of frequency in the radio wave, uh, entire spectrum of radio waves, out of which Ka and Ku bands are used for communication, for any kind of communication, mobile communication, television, radio, etc. So now this Ku and Ka band is what is actually used for just the mobile phone network, for example. So now what happens is that this band is available. Government will say that okay, this is the band available. If you are a network provider, you buy a piece of land. It's just like buying real estate, just like buying real estate, that you buy a piece and that will be given to you, that you will be doing your job, you will be giving your services in this band of frequency. Another one will be given another band of frequency, another network provider. So in this manner the selling of spectrum is done, or allocation of spectrum is done. Right, so I hope I've cleared the questions. So let's, questions related to combat craft also comes. I haven't seen it, but yes, they can come if they are in the news. Of course they can ask it. When all buy from government, why BSNL gives poor service? Because BSNL, first and foremost, BSNL did not buy all that spectrum. The amount that companies like Airtel and Jio have bought, BSNL did not, already making a lot of losses because of its policies, has been making a lot of losses. Government has been trying to bail it out all the time. So that is why they don't have that kind of a money. Today's newspaper is filled with IR. Of course, G20 starts. All right. So let's end the class here. We'll meet back on Monday. We'll finish the remaining portion of this chapter and the last chapter, that is intellectual property rights. Thank you.